All right, let's start this thing. You guys are raffle addicts and gamble addicts and shimmer shillings. I need to see if I can get shimmer shillings made for real. I'd be a millionaire. You guys seem to love them so much. How you all doing anyway? Welcome to Saturday and welcome to the stream, guys. I'm going to start with a bit of Copperberg tonight, just to wet the whistle a little bit. And we've got the Mega65 wine. I am going to have a glass of this on its own first. Before I try mixing it with various things. So it's quite common some places, Germany being one country that does this, to mix wine with various kind of sodas. So and Coca-Cola is one that's quite often mentioned. So I'm going to give that a try tonight. And I've got a bottle of rum as well, just in case. So where can you check the commands list? Oh, good question. I don't know. Oh, there you go. SP's got it for you. Great day. How am I? I'm feeling good today. Actually, I had a little bit of a nap just before the stream, just to keep myself fresh. Probably why I'm happy to semi commit to some rum tonight. Oh, there you go. I've got the command list on the screen as well. That's because I just added the wine update. So, about time Mega65 development. Yeah, Stoker's on the Nest Cafe. Watered down though, right? Not raw out of the jar. I mean, that's when you know you're a caffeine addict, when you're just spooning it out of the jar. Um, Hey, Twitch Eagle, welcome to the stream. Gunstar Hero, yeah, about time for some Mega65 development. So, I'll let you know why I'm doing this tonight. So this week has been incredibly busy. Work has been quite hectic. I've had a lot to do. I've been very tired when I finish work, and I've had no absolutely aqua con leche. Oh, very good. Bit of Spanish in there as well. So yeah, I've not really had a lot of time to do anything this week. So I've literally done maybe half an hour of code all week. And if you combine that with the well, outside of the Check Noise stream, I did some code on the Check Noise stream, but I didn't do any code on the Game Boy stream. That was all mapping. So I thought tonight I'm just going to put the mapping down. I'm not going to do pick and mix mapping, because really all I have to do with pick and mix is put the levels in. I can do that off stream. There's no huge need for me to do those on stream. It's just putting maps together. So I thought I'd dedicate tonight to doing Mega65 dev. So Proud7 asks, what is the Mega65 wine? The Mega65 wine is a rosé, French rosé, from I don't know what that is. Pays dot countries of Ock, whatever Ock is. I don't know if you can see that. There we go. I don't know where that is, but that's where it's from. And it's some bottles of wine that the Mega65 team sent me, with Stoker's artwork on it. So my avatar artwork, really, really, really cool. So yeah, and it's nice wine as well. I'm not a huge rosé drinker. I will drink it, but it's not something I tend to pick normally. So which is probably partly why I'm mixing it as well. But it is nice anyway. But I do want to, another reason I'm mixing it is to try and slow down my my alcohol intake. The amount of alcohol I drink is kind of irrelevant. It's how fast I take it in is kind of been accelerating over the past past few years, so past few months anyway. So I'm just trying to slow it down a little bit so I don't get quite as drunk so quickly. You're in the wine business. You are in the wine business anyway now. We both are. Look. Bottle of Chaland 65. It sounds like a super vintage, but it's not. Okay, let's have a glass of that now before we start. So, what we're going to do tonight, and as you'll see, I've not done very much. Font size in Sublime is quite small. Okay, let me not. Yeah, I tend to knock it down a little bit when I'm doing my own stuff. for ages I was doing the stream and having massive text like this, and then forgetting to turn it back down again. So I was just coding on my own with huge text. Um, it's very weird. Right, let me get the layout right. So I'm going to show you where we're at. It's exactly where we were at last time. The only difference is I've put a different sprite in now. Stoker sent me. Actually, I'll show you the sprites Stoker sent me in a second. Just let me get my view up and get some of this lovely cold wine in me. Um, oh yeah, it's very nice though. You see, this is a problem. If it's nice and it's cold, I tend to I tend to drink it all very quickly. So have I seen? Yes, I have. I've been speaking with them quite a lot over the past week or two. It's really cool what he's been doing. So I've talked to them about Sprite compression, which is what we're going to do tonight, because they've had some really good ideas with how to handle that. It doesn't quite fit for what I'm trying to do, but it's kind of along the same lines, so it's really cool. And they've got really huge sprites on the screen as well, which is cool. So I'm glad that I've got people kind of thinking about the raster rewrite buffer as a sprite system as well as just a kind of HUD overlay system. It's just so much better for it. So let me show you what I've got so far, and if Stoker's all right with it, if you don't mind me sharing the kind of the very rough sketches you sent me. Yes, well, I say very rough. They're not very. They're like for me, that would be the height of art for me, to be honest. Right, let's take a look at the code so far. Right, so I don't have this is all running on the real machine, so I have to show it in this picture in picture here. So I'll try and keep the code that I'm working on this side and resize these windows to fit. So I'll try and keep my code on this side so that I'm not behind, because I can't see. Obviously, I can only see the picture in picture on there. So I was wondering, does the Mega65 support 2 bits per pixel child? So we're using the it's kind of two different things. So um, the Mega65 has quite a few modes. It has 1 bit per pixel, 2 bit per pixel, 4 bit per pixel, and 8 bits per pixel. The 1 and 2 bits per pixel are exactly the same as they are on the C64. So you've got the high res mode and the multicolor mode, where the 2 bits per pixel is just an extended pixel, basically. Um, it's more like 2 pixels per bit sort of thing, if you know what I mean. Um, and then there's 4 bits per pixels and 8 bits per pixels. Raster rewrite buffer is just an extension of the screen, so it just allows allows a single row on the screen to go off way further than the edge of the screen, and just a kind of special instructional language to tell the rasterizer to read a row of characters. But then read another row of characters and superimpose them at various positions horizontally. So the raster rewrite buffer is kind of a little bit different to the graphics modes that you use, but you should be able to use it in combination. And in fact, much like high res and multicolor graphics, where you can have a multicolor screen and use high res uh, like in a few places around the screen, which many kind of artists did, particularly later on in the C64 life. You have the same option with the 8-bit and the 4 bits per pixel mode as well. Um, the difference is that in 4 bits per pixels, it's not the pixels that get wider; it's the actual character itself that gets wider, and the character is 16 wide. Um, I was thinking of the best way to draw 4 colors per char. 4 colors is would still be 2 bits per pixel. That would just be multicolor mode, same as you get on the C64. But obviously, that's got the limitations the same as the C64: shared colors, background colors, things like that. 4 bits per pixel, yeah, as Gunstar Hero says, is 16 colors. So it's 15 and a transparency color. So, well, if you have transparency turned on, that is. You wanted single pixel colors, then 4 bits per pixel mode is probably the best for you. You'll get 16 colors, but there will be single pixel colors. So, all right, let's show you what I've got so far. So we saw this last week or so. I can't remember when I last showed it, and I haven't really done anything to it since then. I've been kind of busy with other things. Um, it loads up. I sorted out my my joystick as well. So actually, do I have a slightly bigger shot? So can I take it to? Yeah, there you go. So you can see I'm using. It looks like sprites, but it's not. This is the raster rewrite buffer. These are frames from Perseus, which Stoker drew, which I'll show you in a minute. I'll show you the full sprite sheet in a minute. It's drawing. Technically, it's drawing 64 sprites, but each sprite is 16 pixels wide and 48 pixels high. The actual character itself is 32 wide and 48 high, so it's actually drawing 32 copies of Perseus. But it's using my kind of raster rewrite buffer sprite system, which makes everything 16 pixels wide. The height is variable between 16 and however height you want it to be in multiples of 8. But yeah, it's pretty good. It's pretty efficient. You can see this raster time down here is the raster time needed to clear this entire sprite layer, to animate it and to redraw it at their new positions. Each one of these characters is made up of each one of these Perseus kind of animation frames is made up of let me think, 12 actual characters. So it's made up of 12 characters that are 16 by 8. So, and each one of those is drawn on its own raster rewrite buffer layer. So you can imagine that there's actually 100 and no, more than 192, 384 separate layers that make up that sprite system. So this is running pretty damn fast, yeah. You're running this at 300. No, this is at 40 megahertz. So the reason why it takes so much down here is because it has to recalculate all 384 layers. Basically, these are each one of these is a separate layer. But you know, it works fairly decently, and it still works over. I mean, there's no adjustment according to the vertical movement of the screen. That's fine. I just haven't implemented that yet. Um, I'm more interested in just dealing with the sprite system itself. So this is all working. I fixed my monster joystick as well, because I was messing around with the control board on it. But yeah, this is what I'm doing, and I think Monsters Go Boom, they're doing something similar. So they're making a framework that kind of does similar things to what mine does. Just kind of with some different kind of limitations and some different kind of specs to it than mine. So, but they're both kind of relatively similar in what they do. I'm really looking forward to what Monsters Go Boom does with it. I don't know what their plan is, but I look forward to seeing what it actually becomes. Right. So let's show you some of the work, the stuff I've got from Stoker. So I've got this Perseus animation now, so you can kind of start to see what our main guy is going to look like. So let me get onto the right screen. There we go. So let me turn the grid off, because where's the? I thought I could turn grid off that way. No. Well, do you know what? I've never actually turned the grid off. I only ever turn it on. So I don't actually know how to turn it off. Okay, let's try Control G. No, Shift G. No, all right. Well, anyway, you can kind of see from there. It doesn't matter too much. So it's an 8-frame animation for his run animation. So Perseus is going to be. Oh yeah, let me add the points in the quiz on. There's your points. Put the quiz on 25. I think 25 has been the best kind of value for this. And we start straight off with an N64 game. Sean will be so upset. He misses them all. It's hilarious. And then when he does get them, they're like really, really obscure games that he's never heard of. So you see, he needs to play more Commodore games. He needs to get streaming from that bloody Commodore I sent him 18 months ago, whatever it was. I did not know there was an N64 Paperboy. Wow. Okay. Interesting. I kind of want to play that now. Never knew that. Yeah, so this is the beautiful sprite that Steps has not Steps, sorry, Stoker has sent me. So the idea, let me just go quickly over the Perseus idea again. So Perseus is a character in Greek mythology, quite a famous character in Greek mythology. Is the one that killed Medusa. Um, and he's got a really kind of good kind of lore behind him and history behind him. There's a lot of interesting stuff in there. He's known as a monster hunter as well. So the idea is this game is going to be about Perseus, the monster hunter. But the set we're changing the setting a little bit. So instead of Perseus being in ancient Greece, Perseus is probably going to be in a kind of modern Greek steampunk setting. So it's more like I think what the setting's more like. It's kind of hard to say actually, but I think both me and Stoker have got the same kind of vision in our head of what we want it to be. And I'll show you in a minute some concept art that's been done. Um, and it's got me so excited. So, but yeah, this is the main sprite. It looks really cool. It's kind of I haven't got it animated at the moment. But yeah, trust me, it will be that kind of setting. Are you making Hawkeye? Not quite. So what I'm trying to do is I'm trying to make my aim is to try and make something that we can release with a Mega65 when that comes out. So I'm setting myself a target of 12 months or so. If I can get something done quicker than that, then great. But I realize there's no way I'm going to make the game I want to make, and I'm pretty sure Stoke wants to make in 12 months. So I'm trying to come up with an idea which allows us to create a vertical slice of the game. So a fully functional game that's basically a demo of um, a demo of the game, but with enough content that it lasts. So one of the ideas I've had is to create levels that can be reused. So in the same way that Mario 64, you go into a level and you do each level 6 times at least. Some levels are a little bit more. There's bonus stars and stuff in. It'll be something like that. So there'll be quite a large level that you can move around, but your mission on each time you go in will be slightly different. And the idea is much like Mario or probably more traditional RPGs, actually, rather than Mario, is as you go along, you'll gain abilities and you'll gain experience and some kind of currency to kind of expand a little bit more. So port flashback. I don't want to do this is what I'm trying to avoid, you see. So I was going to do Raiden, and I couldn't find even where to get the license from. Never mind to actually chase it down. It seems to be some Japanese mobile company now that owns the license. I'm not even 100% sure on that. I wanted to do Turrican, but I think Factor 5 just are probably never going to allow that to happen without a hell of a lot of input or restrictions and probably cost as well. So that's not gonna happen. So I decided I want to do a game that's just 100% a new idea, new kind of IP, something that we don't have to get permission from anybody to do. But in order to do that, I need to get a good artist on board. And the reason why I'd never done this before is because I could never find yeah, but Factor 5 are the only people that fight. Yeah, exactly. It would have been very, very, very hard to get. I mean, I had some contacts that may have panned out, but it's still well, I still haven't heard back. So yeah, I'm not too fussed. I'm happy to do this, but the reason I didn't, the reason I was always going for ports was because it's easy to do the art, right? I just port the art from whichever version. With Turrican, it was the Amiga version. Um, but Stoker's, so and I put the kind of call out to try and get an artist for this. Um, Stoker's stepped forward, and honestly, the stuff so far has just been brilliant. He's really enthusiastic about it as well. There's a real kind of you can tell we both understand what this game should be, even though we don't know what it should be yet. That we both know the direction we should be taking it in. Um, and as we go along, we come up with ideas. So for instance, there's things like when you kill Medusa, you'll gain a shield sort of thing, which will help you further on in the levels and stuff. So you'll gain powers as you go along. So it's going to be kind of not quite an RPG, but there's going to be some kind of progression to the game. That there's going to be ways to kind of complete levels later on, or you know, come back to levels and do things differently, or reach areas you couldn't reach before because you've had some upgrades or whatever. There may be some kind of skill tree as well that you update. So it may be semi RPG like, but not not too RPG like. Yeah, tech tree sort of thing. Yeah. So yeah, this is the animation he sent, and that's what you can see spinning around on there. Is the first frame of that. Um, the reason I've got this in here is because I've been writing the script to actually export this and put it in, and that's what I'll go over once I've explained a little bit more and shown a little bit more. I'll explain why we're going to do the sprite caching tonight. Hey, Vintage64, greetings from Texas. How are you doing? Wow, Texas. How are you in Texas? Because I realize there's a lot of issues with power, isn't there, and stuff at the moment. So it must be kind of hell at the moment there. Um, but yeah, greetings from London to Texas, and I hope you get manage to get everything sorted out there and get the power back on. Power and water as well. Wow. Okay, that's kind of bad. That's kind of bad. Well, I hope that I hope that the the stuff there gets sorted out pretty soon. So fingers crossed for you anyway. Fingers crossed. So I'm just going to show another clip. So this is some concept art that Stoker sent me. I think it was yesterday or last night or something. This is gorgeous. I absolutely love this. So I'm going to open it up in here. And this is kind of the look and feel of the. So this is just. So I think Stoker was doing some kind of palette test just to get an idea for the look and feel of the backgrounds, what the tiles would look like, what the background planes would look like, and how the character would fit into those as well. So this is what he's come up with, and I really like the style. It's got that Victorian steampunk feel to it. I really like the cog as well. There's something about this. I used to play a game. Oh god, I can't remember what it was called now. It was an RPG on the Xbox, I think it was. I think it was on lots of them. It was a Japanese RPG anyway, turn-based thing, and it was set in a very similar kind of steampunky world with lots of cogs and stuff everywhere in it. It just looked really nice. So I'm really into this I'm really into this style of things. I'm trying to work on systems to kind of increase the amount of memory we have for these kind of things. And it gives me an idea as well of the sort of things we want to do with the character as well. So Gunstar Heroes mentioned flashback, and I think there will be a little element of that maybe in the control system, with Perseus being able to grab onto ledges and drop down from ledges and things like that. So and much like flashback as well, the map is going to move around in all directions, so it's not just a straightforward horizontal thing. It's going to be a map that moves all over the place. um, whether it's going to have the kind of puzzles and stuff that flashback has, I don't know. Probably not. It will probably be more based on shooting stuff and having the power to kind of jump certain distances and stuff. But it looks really good. I love the kind of style of it, and for a mock-up this is incredible. I mean, just shows what kind of artist Stoker is, and I'm really excited to be working with him on this. But yeah, we're gonna attempt to get a level of the game like this, in a one particular style, um, kind of ready to be kind of it's kind of like it's going to be kind of like a demo, but it's more going to be that it's a single stage of the game with enough content for you to kind of get excited about it. But so in that case, it is like a demo, but it will be almost completely fully functional. Everything that you would expect to be in the game would be there, and really all we'd be left with is designing other levels and other challenges as well. So but it looks really nice. I love the style of it. I love the ideas that have been kind of put forward so far. And I'm really looking forward to getting stuck into it. Like I said, I haven't had a lot of time to do anything recently, so it's going to be good to get into that. Hey Cosmin, hey Cosmin, how you doing? Okay, uh, let's take a quick look. Oh, okay, but yeah, speaking of which, actually, vintage. We'll have a chat at some point as well. I know I've been meaning to get back to you for a while, but I've been so busy with work. Um, we'll have a chat about this a little bit further as well, and maybe I'll introduce you to Reese, who's Stoker, and we can chat a little bit between us about the game. Um, but yeah, this is kind of the concept we're going with, and it seems to it's in my head it fits really well, and I think we've got a kind of good connection of what we want to do, which is nice, and the enthusiasm to do it. So let's explain about why we need to do sprite compression. So the Mega65 has at the very basic level, it has 384 kilobytes of fast chip RAM. So this is RAM that's access that the VIC 4 can access, and the well, likewise the VIC 3 as well. But it's a RAM that can be accessed by the VIC 4 at full speeds. Um, so that gives us 6 banks of 64 kilobytes. Now, code needs to be running in the first bank. So much like the Commodore 64, your code runs in that first 64 kilobytes. So that area is kind of, it doesn't have to be reserved for code, but your code needs to run in there. You can't run code in the higher areas. The only way you can do that is if you map code in, and you're still mapping it over stuff in the bottom 64 kilobytes anyway. So that's the first 64 kilobytes. Now that leaves us with 320 kilobytes. So it leaves us with 5 more banks, which sounds like a lot. 5 banks of 64 kilobytes sounds like a lot. But let's take a look at these sprites. So you can see here, each one of these sprites is made up of 16 by 16 blocks. If I want to put this into character mode, this is what you actually get. These are the characters. Each one of these is a character in memory, and each one of these is 64 kilobytes, 64 kilobytes, 64 bytes in memory. So you can see one sprite takes up 12 blocks of 64 bytes. So that's 768, I think. Hang on, let me put that in here. 12 times 64, yeah, 768. So each sprite takes up 768 bytes in memory, and we've got eight frames here. So you can see already we're up to 6 kilobytes just for the walk animation. Now, if you multiply that by all the different animations, so we might have a walking animation, a shooting animation, a turning animation, a jump animation, a death animation, it's soon going to build up, and we're gonna far exceed 64 kilobytes. Now, luckily, we can use duck, jump, exactly, quite a lot. And in fact, with 64 kilobytes, we get, hang on, 65536 divided by 768. We get about 85 frames. 85 frames sounds okay, but this is just in one 64 kilobyte block, and we've still got enemies to do. Um, lots and lots and lots of little things. Um, and you've got to remember that we've got 320 kilobytes left for everything else other than code. So that's our sprites, our backgrounds, our music, lots and lots of stuff. No, yes. So one of the things we'll be utilizing, and this is one of the advantages using the raster rewrite buffer to do these sprites, is we'll be utilizing the hardware flipping of characters. So characters can be flipped in the raster buffer very easily just by setting an attribute. It's an attribute based flip, much like it is on many other systems. I'm gonna have a wine and coke. I'm gonna try it out. Skip the top row and have him run around headless. Just someone called Spooky Coda to say that. Right, let's try this out. I don't know what sort of quantities I'm supposed to put, so I'm going to go half and half. See how that works. So yeah, we save some memory by only having to draw things in one direction, because we can use this hardware flip to flip things. And actually, that's one of the advantages using the raster rewrite buffer. We can't do that with the hardware sprites. We can only do this with the raster sprites. So that's one of the advantages of doing it this way, is we can actually flip and reuse things. So write routines to draw sprites internally in code rather than importing, draw them out through the routine pixel by pixel. You'd be saving memory. um, yeah, I mean, I kind of get what you're saying at, but then that takes a lot of artistic that takes a lot of art out of the thing, because you'd either have to write stuff that was very very simple, or you'd have to write something which just plotted line by line, and that would just be more than it would to have the code. um yeah, I mean, there's probably some reusable frames in there in a few places. But the system I'm going to go for is a sprite caching system. So what I'm going to do is I'm going to reserve probably around about 28 to 30 kilobytes of memory, and this is going to be the sprite cache basically. And the reason I'm using that much is because I have a system set up to load up to 64 of these kind of large sprites at once, and that's enough memory to store those 64. And but when I say large sprite, I mean half of Perseus basically, like that. So a 16 pixel wide strip of Perseus. Um, I've got enough room for 64 of them in that area. And what I will do is by making sure that the sprites are always pulling from that 32 kilobyte bank, I can guarantee that the most I'll ever need to have loaded in at one time is, well, 30, so it'd be less than 32. It's going to be around about 28 kilobytes. And there's a reason for the 28 as well, rather than a higher number, and I'll explain that as well in a minute. Um, and why we're not just rounding up to 32, that is. Right, let's try this out. Oh, that's actually really good. That's really good. Well, I recommend that. Rosé wine and cherry coke. It's a strange combination, but it really works. Mm, that's not going to last long like that. And then what I'm going to do is each one of the sprite datas like this. Actually, it will be again in strips like this. Each one of these is going to be compressed and stored somewhere else in memory. So what's going to happen is when a sprite is required, it's first going to go and look at an index, and this index is going to be a list of all the possible frames that we can load, and that index is going to fit in 4 kilobytes of memory. And the reason it fits in 4 kilobytes is because it's going to fit right on the end of the sprite cache. So you got the sprite cache at 28 kilobytes, and then you got a 4 kilobyte kind of index, which we can use to look things up. So it'll go and find the frame it needs in that index there, and that index will tell it, is it already cached? If it is, then we just point the sprite pointer to the new sprite that's to the sprite that's already cached. If it's not, then it just runs a very short decompression routine, which is going to decompress half of a sprite at a time. So it would be 300 and 384 bytes at a time into the sprite cache, and then mark it in the index as having been compressed in there and been used one time. Anytime a sprite changes, it goes back into the index and it knocks one off its usage count. So each sprite in the index will say, is it cached, and how many instances of the sprite are being used right now. Um, and it's that simple. That's all that's going to happen. And then when a sprite is no longer being used, it will have a count of 0, and that means the next time a sprite needs to be made, that sprite can be needs to be decompressed. That sprite can be loaded into that area, and that's the sprite area being reused. The disadvantage of this, obviously, is it's going to take some processing time to decompress these sprites. Pardon me. But the advantage of this is we can fit, even with a basic run length encoding, we can fit twice as many sprites in the same space. So by sacrificing 32 kilobytes up front to have a cache, we can then use the remaining 32 kilobytes in a bank to gain a full 64 kilobytes worth of sprites, which means if we use 2 banks of 64 kilobytes, we actually get the equivalent of round about it would be 3 times this. So it would get roughly 256 different frames that we could display in that. And that would leave us with 3 more banks which we could use to store the character, the backgrounds, and the music. I think with this, we're probably going to have to go with SID music, because the problem with mod music is it takes up an awful lot of memory. So unless the Mega65 spec changes, and there is a small chance it could change. I know Paul is making some changes to the memory pipeline, and at the moment, which could open up the room to have a little bit more memory. If that's the case and we do get a little bit more chip RAM, then mods may be back on the table. But I think if we're just on 384 kilobytes with the scope of the game as we have it, I think it probably makes more sense to use dual or quad SIDs instead, as that would be a much smaller anyway. So yeah, that's what we're going to do tonight. We're going to set up the Sprite caching system. I've already got the Sprite system in place. As you can see, it's doing its job. You can see there down there in the corner. But what we're going to do tonight is we're going to intercept some of the calls to generate the sprite data, and to load the sprite data in as well. So at the moment, what's happening? Let me show you in the raster. The raster rewrite buffer sprites. At the moment, what's happening is we're just assigning these pointers directly. So we've got 16-bit pointers for the sprites, and we're just pointing it directly at areas of memory. If you do it my way, you're using half of the memory needed to import the child. The alpha section of the sprites doesn't exist if you just routine. Yeah, but I mean, you are still not going to be able to detail a 16 color sprite of that size in less than 768 bytes. It's just not going to happen, because the detail is, there's not a lot of solid blocks of color in there. If there were, then the compression routines would be better, because there's a lot of kind of dithering and stuff going on in there. It's very hard to generate that in any kind of any format that would work. But it doesn't really matter. The compression routine will halve the amount anyway. Hey, old Skunk Coder, welcome. Yeah, dual SID with sound effects in the third, fourth. That's probably what will happen. Yeah, exactly. But I mean, essentially, what Gunstar, what you're saying, Gunstar, is this kind of same as what we're doing anyway. It's just it's compressing the data to, we're just finding a way to use less data to generate the sprite. So the advantage of doing it the way I'm doing it is it's going to work with all types of data, even if the data is kind of very randomized, very noisy randomized, like dithered sprites, stuff like that. And the runline encoding format that I've come up with is fairly decent. I mean, it takes it down to about 40 to 50% of the original size. Hey ZX Specky, welcome to the stream. Oh man, it's so good this. You're simply dead, yeah. You know, you can still use the raster rewrite buffer in basic. I mean, I don't know if it's actually hooked up in the emulator. I assume it is actually, but you should still be able to use it in basic. Although you probably have to do poking and stuff to do it, but you would still be able to technically to use it. So um, there is a basic. Oh, okay, cool. So it does exist then. Yeah, there's no reason why you couldn't use it. Because the other cool thing with the raster rewrite buffer is it doesn't take any extra processing time to draw away from the CPU. That is to draw all these layers. Right. The only time that you use in CPU time is when you need to change the contents of these layers. Once these layers have been set up, they will just draw instantly. You know, there's no additional CPU time. The only reason you see this this bar at the bottom here is because it's updating 384 layers to draw all the different characters that make up these sprites. It's having to clear them, reposition them, and redraw them. So I'm not going to click that. I'm scared of that. Oh, be a basic 10 example. All right, okay. It looked like a dodgy URL because it came up with a it came up with a clickable link. So, all right. So what I have done already is I wrote a very simple run length encoder. I'll explain that a little bit. Let me just move this over here. So this is just in my my export. At the moment, I'm bypassing it because let's just turn it back on. I can show you the results in here. So if I just go to what am I looking for here again? Mega65. There we go. Perseus. I really need to sort this folder out. It's just a bit of a mess at the moment because it's kind of mostly kind of experimental stuff. So, but I have this sprites file here, and the sprites are taking up 7,168 bytes. That's how much memory it's taking up to store these sprites. And the reason for that is as well as the size here. Let's do this with the calculator so I can show you. So each sprite is 768 bytes, which gives 6144. But each one also needs an empty space above it. So it needs two characters of empty space. So we need 128 times 8 as well. Oh, 6144 plus 128 times 8. Wait, what? How's it failing to do the maths here properly? Yeah, there we go. And that's how we get that value here. Because it needs that blank space. So the other advantages, of course, of doing compression is we don't need to store that blank space either. So I'm going to keep that there. I'm going to delete this one here and just call this unpacked, so you can see the difference with the compression scheme that I'm using. So the reason I'm going for run length encoding rather than a more aggressive compression tool is because speed wise, run length encoding is going to be way quicker to depack than, for instance, a LZW kind of an LZ algorithm, um, which will compress it a little bit better, probably another 10-20% on top. But unfortunately, will um, you just lose out there? I can see the no. But unfortunately, will take a lot longer to decompress. So there is actually a really good post on Codebase. Let me just show you that. Which again, I was talking with Monsters Go Boom, and I shared this particular post because we were talking about the the efficiencies of various compression algorithms. And I found this rather useful post. It's kind of a little bit dated, but it still gives you a very good idea um, what the compression algorithms are like. So there you go. And you can see the higher up this chart it is, the less the compression is, and the further this way it is, the slower the compression. And you can see run length encoding is by far the fastest, but it's also the least compression. But I'll explain why that's not too much of a problem for us as well in a minute. Um, and you'll see that actually the compression is much better than that for us. Um, and you can see that the best algorithms are things like for compression size are things like X and Y and stuff like that, but they're 6 or 7 times slower than a run length encoder. So for those who don't know what a run length encoder is, it's quite simple. It takes the data as a stream of kind of values, and it just anytime there's more than one value that's the same. So you can see here we've got a whole stream of transparent pixels here. Instead of storing each one of these as a separate byte, it will just store a byte that says put this character in this many times. So usually it's done with 2 bytes. You'll have a character and a length. Uh, did a video, but yeah, we've done some of this before as well on stream. We have done a few things on this. I think I touched on run length encoding in some of the pick and mix streams as well. But what it basically does is mean when you've got long contiguous blocks of like the same color, it can reduce those down. So generally what you do with the run length coding is if it's more than 2 of the same color, then you run length encode it. Otherwise you just put it in as normal. So this block here would be run length encoded, this block here would be run length encoded, and so on and so on. Now, the one thing I noticed and thought about while I was looking at Sprites is, well, actually, there's a special case in Sprites. Have you looked at vertical strokes rather than horizontal? Tiny view worked better in vertical mode. I haven't, but there's a reason. There's another reason why that probably isn't going to be great, and I'll explain a little bit as I get into this. So one of the things I noticed with this is all sprites tend to have one thing in common, and that is they have large blocks of transparent color, right? And that's the same on almost all sprites. Almost all sprites are going to have these large blocks of contiguous unused color. So what I've done is I've made a special run length case which uses a single byte, and it's a single byte to describe a block of transparent color only. Transparent is always color 0. And so that's why my run length encoding is slightly better than normal. Blocks of transparency is treated as a single byte. Blocks of any other color are described with 2 bytes, and any single colors are described with single bytes as well. That gives me this compression scheme. Let me just find the code. God, where have I put it now? Shit, I've lost it. It's in the middle of all this crap. I was going to share all these as soon as I've got something I'm happy with and I know that it's working. I will share this with you guys. Yeah. So what this does is there are if a character value is less than 128. So if it's a positive number, then it's just going to display those colors correctly. That particular byte at that location correctly. If it's more than 128, then it falls into, in other words, it's a minus number. It falls into one of 2 camps. If the number is between 128 and 192, then it's just a normal run length encode, and it's 2 bytes that describe the block of whatever color it may be. If it's 192 or more, then the encoding describes just the transparency. So let me just change this code to output the right thing. I think that's right. Yeah. And do a run. Now the sprites are going to look completely wrong on here because obviously they're going to have been compressed and they're just going to look like noise now. but I should be able to see the size difference. So before we had 7,168 bytes. See, they're just blocks of noise now. But our new sprite size is 3,435, so it's just less than half the size for the same data. And so this is what we're going to go with this system, at least for the first iteration. What I think I'm going to eventually do is allow you to compress these in whatever format you want to compress them, and either have an algorithm which picks the best one per sprite, or have a way of marking sprites like that, and actually have options in both the exporter from Sprite and also the importer from the Sprite system as well. Small sprites, can't you just use two nibbles, one for color or one or count? Would you really get 16 bits as you? Yeah, so I thought about this a little bit, and I was trying to think of a way to save bytes in places. But if you imagine an area where you've got alternating color, so you've got lots of single pixels of color, which we do have in this. Like for instance, this block here, right? This is all different colors stored in single nibbles, right? But how would you go about displaying those? You would either have to sacrifice one color so that you could use it as that color as a marker to say this is run length encoded or not, or you would have to actually expand these into from nibbles into full bytes to display them. So that has a problem as well. But I'll explain why I'm doing it this way as well, because when we unpack, one of the things, and this is why it's not vertical as well, one of the things we'll be able to do is whenever we get to a run of color, say we reach a spot like this where it's going to be this entire block up here plus this block here, right? So this is going to be what, 20, 27, 28 pixels of the same color. Now we could just store them in a loop, 27, or we can use DMA. So we can use the DMA system to very quickly drop these 27 in at much faster speeds than if we were to do it manually. And that's why the DMA stuff is going to be really useful for speeding this algorithm up, and makes it more difficult to do. I know you can still do it vertically because we have step DMA as well, but I think it would be a bit harder to get that implemented right. But it may be another algorithm later. The whole point is we're what the hell is wrong with this streamer getting proper technical stuff? Yeah. The whole point of this is that the compression and decompression routines are going to be abstracted from the sprite caching system. So all the sprite caching system knows is go and fetch a sprite, and that the actual decompression routine can be whatever you want it to be. For now, it's going to be a run length encoder and decoder, but you could swap it out for whatever you want to swap it out for. All this is going to do, all this script is going to do, is generate that data, but also to generate the little table which tells it where each sprite is in memory, and where and the bytes it needs to kind of to store things like cache times and stuff like that. They're cached instance counts and things. So you'll see. It's not there, is it? Where is it? Yeah, I have this here, which is it says Sprite index. I'm not actually saving it. I should probably save that. Let me do that now. So this Sprite index is basically the file which contains all of the offsets for the sprites into the data. It also has a sprite base attached to it, so you can actually tell it exactly where in memory these begin. So this will actually have absolute addresses to stuff in memory. And then it stores an extra 5 bytes spare. So these 5 bytes spare are going to be where the sprite has been unpacked to, an instance count, and a spare byte for something else should we need it. So I'm going to make sure that saves now, which I think it does. Sprite index, yes. Okay. So just to run that again, hopefully I should get a sprite index. Actually, this is going to be oh no, it's not going to be 8Ks. It's going to be yeah. So 4K index will give me 512 sprites. 512 sprites requires probably most of the upper RAM. Um, hasn't, oh yeah, as there we go. Yeah, so it's only 128 bytes. Eight bytes for each sprite. We've got 8 sprite frames, so it's pretty good. So anyway, that's kind of the theory behind it. Now I've spent an hour talking about it. Let's actually crack on and get into it. See what we can do. So I'm going to turn off the little picture in the corner. There's no need for that to be going around distracting. And let's go ahead and do this. Actually, do you know what? I'm going to take a quick 2-minute break just to go to the toilet. And then when I come back, we'll crack on. All right. So let me set the races off. And I should be back in 5 minutes, guys. Be right back. All right. I'm back. Oh, C64 quiz. I feel like that's the first one tonight. It's been a bit of everything, hasn't it? Trying to see what it is. Sorry, I played the quiz. I should be talking, but I'm just playing the quiz. Oh, that wasn't a bad guess, actually. That did have the kind of Platoon look to it, didn't it? But it's very much not Platoon, though. But it did. I could see where you thought that. Oh, god damn it! Of course, right. Okay. So the first thing I want to do is I want to just add something that I realized I should have probably put in here, which is an end character. So when we've finished, we should be putting a character in which says we're done now. Um, the most obvious one to do here is to output 255, but that would mean that we probably need to limit how many characters can be done in here, because otherwise this could get confused. So I'm just going to drop this down to 62. I mean, it's unlikely we're ever going to hit that value anyway, unless it's a lot of man, I thought I'd put that on 25, not 30. Okay, there you go. Okay, cool. So that's just going to ensure that the data that we output actually has an end, because otherwise, when we're unpacking, we're going to have to count where we're at. And while we could do that, the count is going to have to be more than 8 bits. It's going to have to be 10 bits. In fact, it's going to need to be, and that's too much really to deal with. It's going to be a bit of a slowdown as we work out have we actually flipped that 10th bit. Because you need to know, have we flipped the 10th bit, and has the 9th bit just been flipped? And that would be how we tell. Also, the sprite size is variable. You can see in my sprite options up here, sprite height here. So you can pass in variable sprite heights, and it will divide these up accordingly. As you can see here, these sprites are 6 characters high. So that's what I pass in. So the only thing I need to do is I need to pass in a base value as well. So my make file over here is what's generating the sprites. And at the moment, all it's doing is generating the sprites. I'm not doing anything else. And you can see if I, and there's my sprite height there. You can see if I load up the sprite index into here, you'll see the addresses are all set to 0. And this is because all the in fact, why are they all 0? They should be incrementing. The first one should be 0, sure, but the next one should be incrementing along. Okay, so that's the first thing I need to fix, because it should be making a record of where each sprite starts in memory in terms of the compressed data. So let's just go and check why the hell that's wrong. It's probably something really simple, and I know don't really like doing JavaScript on stream, but I guess we're going to have to do this. Sprite data dot length. Okay. Sprite data concat. Oh, I mean, it should be. Okay, I mean, this should definitely have a length value, and I don't know why it's not got a length value in it. Plus sprite base. Oh, hang on. FF, not 0F. We're working on bytes, not nibbles here. Praise be the spiral, indeed. Oh, and it's still not. It's still giving me zeros in here. Okay, let me output the. Let me just print this out as I go through. And this should hopefully display down here with the right values. This is the only thing I need to do, and then we can crack on with some actual 45 GSO2. Ah, there we go. We've got not at number. Okay, so that's probably because sprite base is wrong. Yes, it is because for some reason I didn't finish doing that. Why? Oh, okay. I was halfway through doing it, and then I stopped. So I need to do this. There we go. Right. So get rid of that line. I'll leave it in there in case I need to just turn it back on again, but that should be fine, I think, now. There we go. So you can see every 8 characters, we get a new, uses 3 bytes. So it's using a 24-bit address. The memory goes up to 28-bit, but 24 is plenty here. But you can see, we've got an address. So the first sprite is at 0, the next sprite is at 00C0, then it's at 01BB, and these are offsets from the sprite base, which is basically where is the sprite data loaded in memory. Well, at the moment, the sprite data is loaded in a temporary location. It's just at 8,000. So we're just going to set that as our sprite base because that's where the sprite data is being loaded in. We're actually going to use somewhere in a higher memory for this eventually. Chars are being used there, so I'll use a value somewhere around there. I don't know how big that chars file is. I need to find that out actually. Let me just quickly have a look for that. Chars 77. Okay, so I could use 3,000 or so as my sprite offset or something, or 2800. It doesn't really matter. That's where the frame's going to be, but yeah, we'll change. Let's move main over here because I'm not going to do much. Not going to do much editing directly in main. But yes, we're going to set our sprite base to be 8,000, and we do that just going in the make file. We go into this, which I'm going to set on word wrap so it actually see it on the next line. And much like we set the base for the tiles in building the tile output, we can set the base for the sprites as well. And this is just telling it our sprite base is at this location. So now when I compile and I go back into here and grab the sprite index, you can see they start at 8,000. And then the next one, 80C081BB. And this just means that when I'm loading in, I don't need to add an offset. It's already pre-calculated for me. So we're just going to save a little bit of time. So yeah, he bought the merchandise. Yeah. I'm not wearing. I'm wearing a Thalamus t-shirt tonight, which is it's becoming very tatty. Actually, I might need to get a fresh one. It's a bit beat up, this one. I don't often wear a white t-shirt on stream, do I? Generally, I wear black t-shirts on stream. I tend to wear black t-shirts all the time anyway, but the shirts are as UK size, not US size, so they're bigger than expected. Okay. Yeah, I found, yeah, I think that shirt's just about the right size. I take a 2XL. I'm a bit of a fatty, to be honest. I have to say, wine and cherry coke, very good. But I've also grabbed a can of Fanta, so I'm going to try wine and Fanta because I'm on a mission now to discover all the things that white or rosé wine goes with. You got an XL and it's a little big. That was the hoodie though as well, wasn't it? So, oh, SP, you got a bottle of Kraken. I've got some Kraken behind me. Oh, you can't see it. It's just up on the shelf up there. So, I'm if you open the Kraken, I may open a bottle of Kraken. Oh man, that's good. Why have I not been drinking wine and soda? I know of white wine and soda. I know that's a thing because like it's quite a common drink over here in pubs and stuff. But I've never thought of actually using flavored soda, and it's actually really nice. Release the Kraken and Perseus will get him. Yeah, that's one thing I'm really looking forward to doing is working on the bosses. The raster rewrite buffer gives us the opportunity to do these huge bosses, um, and will be really cool. I think. Oh, the limited, is that the one with like in the black clay bottle sort of thing, the black ceramic bottle? Yeah, I've had one of them. I think I got one of them given to me as a present from work when I left work. Say left work when I moved to a different floor. Okay, so I think our data is fine now, so we can go ahead and start building the rest of this. So first thing I'm going to do is I'm going to put the sprite index in as well down here. So just need to check where our memory is. Uh, okay, yeah, we've got loads of room down here. So I'm just gonna, for now, I'm just gonna assume it's going to be 7K, and I'm just going to put it here. And this is going to be our Sprite index. Now, again, this won't live here either. This will live somewhere in higher memory. But for now, I'm just going to put it here, and we'll work on where it needs to be later on. Now, where these sprites get exported to is a different matter. That's down to the caching system to work out where they go. Um, I need to work out where the end button is on this keyboard. I still don't actually know. Sprite index.bin. Yeah, there we go. Okay, so now we have some sprite data which is imported into this location, and so the index data is important in this location and points to sprites at this location. So let's add a new file into the it's called screen. I should change it. It should be framework really now. This I'm going to call this sprite cache because that's what it is. I'm going to save that out. Let's make it like that. Okay, so how's this going to work? So what we need to do is we need to have a way of knowing when to cache the sprite and how to cache the sprite. So at the moment, what we have is we have these pointers, and these point to directly to the sprite data. I'm not going to change this. This is going to stay the same because this is technically the low level code for the sprite system. This is just saying here is where you can find the sprite data, render it please. This is going to stay the same. This isn't going to change. This is still going to point to these areas of memory correctly, and that's how I want them to work. What I do want to do is create a system where I can probably in the sprite cache system actually where I can define what I want what I want each one of these to load in. So or a list of I need to think about how to do this, you see, because what we don't want to do is we don't want to do it halfway down the screen, because what you don't want to be in the situation is where you're halfway down the screen and suddenly the caching system has said, okay, we need to change what this sprite is, and it's going to go off and it's going to unpack a different frame into a location. Now, in most cases, that would be fine. You'd get the same effect that you would see on the C64, where the sprite would just change halfway down like you would change the pointer. But in the case where you had a screen full of sprites, so the full complement of sprites, you would actually be in a situation where actually no, it would be the same, wouldn't it? So maybe it is fine to change it immediately rather than force it all into the V blank. I just have to think about this. So if I wanted to change, I've got 64 sprites on screen, and I want to change one of them. Is it fine to immediately at that point go and fetch that sprite data? I think it probably is. I don't see any reason, now I think about it, why that would break. Well, we can do it that way, and if it causes problems, we can strip it back. Batman tattoo? Where? Over here? Over here? You mean? No, Vader's him. No. If you're talking about me, that is. Oop. Yeah, this is all Invader Zim. I'll show you now. Invader Zim, and Gaz, also from Invader Zim. I have a thing for Invader Zim. It's cool. I think that's why I like Final Space so much. It's got a kind of a bit of a feel of Invader Zim about it. Not quite the same, but it's amazing. Oh, have you got them on in the house? The it comes in the house collection. Special edition, I think, comes in the DVD collection comes in the house. Okay. In which case, what I want to do is really just have a routine which says, okay, let's call it change sprite. So what this is going to do, this is going to take an index from here. So say we pass change sprite, and we want to say, let's say that the trying to think what registers to use here. Let's go. Well, let's just put what we need. Let's make them X and Y for now. X is our target sprite index, which is the index into this system here. Let me close that thing down. Hey, Zupaden. How you doing? So yeah, we'd have our target sprite index in X, and then we would have our frame index here, and this is our source frame index. So our frame index is the number in this sprite list here. So this would be 0, this would be 1, 2, 3, 4, 5. Remember, each one of these is made up of 2 sprites. So that's the system we're going to go with that. So we're basically going to call this routine. This routine is then going to do a few things. Let's mark them out with some kind of comment code, some pseudo commented code. Okay, so first step. First step is we need to fetch source frame from sprite index. Then is frame already cached? so, if so, set sprite target pointer to match and increment usage count. Actually, I'm not sure about the usage count here because hmm, no, it has to be. We have to have a usage count because we need to know when something's ready to be reused, right? Um, hmm, okay. Uh, maybe Control Z helps you. It's like pro programming tip. What? What are you on about? You mean undo? I mean, okay. Okay. I was confused, but it's like, okay. What do you call a boomerang that won't come back? So, fair enough. Uh, when watching channel, I get both encouraged and don't get discouraged. Don't get discouraged. Okay, so actually, before we even start caching, the first thing we need to do is the current mm, is same as current target frame. In other words, no change. So just exit. Because if it's the same thing, we don't need to do anything. We just exit. But we could reach the case where we're trying to set the same frame number every frame, and we don't want to have to keep kind of going through this. Um, if not same, then decrease current usage count. Current frames usage count. So what this is going to do, this is going to say, okay, this isn't the same frame as before, so we're obviously going to replace this. So if we're going to replace this, we can mark off one instance in the usage counter. And the reason we need that usage counter is because when that usage counter gets to 0, that means that sprite can be reused. It can be technically garbage collected, although we're not really garbage collecting, but we're saying we can reuse this block of memory and we can do what we want with it. Um, uh, Yeah, I mean that's true, Cyberfly. I have been doing this a lot. I mean, I've only really been back into ASM, say, for the past 4 years or so, 3 or 4 years. But I did do it a lot in my youth, and I have coded an awful lot in between. Not just not assembly. I've been doing other languages as well. Um, but honestly, assembly is not that difficult. I think assembly is easier to learn in terms of the commands themselves. And kind of basic program structure. It's easier to learn than almost any other language, especially 6502, because it's there's not a lot to learn. There's really not a lot to learn. The trick becomes learning the memory maps for the systems. That's the hard thing, because then you've got to learn. Okay, I know how to do pretty much anything I want to do with numbers, but how do I make it? How do I make it do display a color on the screen? How do I make it do this? How do I make it? And understanding the hardware is the tricky thing. Um, but the same thing applies to high level languages as well. It's just that is some of that kind of hardware technicality is abstracted away from you, and you stop worrying about it so much. And it's a combination of the high level language kind of removing you from that by abstracting things out. Like when you draw an image in the browser using just using HTML, right? It's so abstracted from what's actually going on, that you don't even think about um, things like oh thanks for the gift sub, Super Dan. Very much appreciated. Ian to Blitblop to Kevin Landwaster, I like that. Magicaris and Buzzley. Thank you very much. Appreciated. Cheers. Yeah, when you draw an image in the browser, it's abstracted so far away. You don't think about how OpenGL is actually, filling a vertex buffer and sending a texture into the GPU's texture of texture RAM and drawing that to the screen. And you have to think about that more with ASM, so it gets a bit more complicated. But actually, learning ASM is very, very simple, and learning the memory maps is just about practice. Just honestly, as Cyberfly, just do it every day, and you'll get the hang of it. Uh, how do you get this language to do exactly what you want? And that's why I always say, writing games is for me the easiest way to learn, because I can set myself a load of targets. Say, I want to do this, I want to do this, and I want to do this, and I may only know how to do 10% of that in the language that I've chosen. But by setting myself those targets, I have to go and find out how to do those things. I have to investigate, I have to research, I have to figure out how to do those. So, yeah, that's how I do that. But yeah, thank you for the gift sub, Super Dan. Very much appreciated, and nice to see you on the stream again. I have to say, Fanta and rosé wine is very good. I think because it reminds me of Bellinis and things like that. It reminds me of those kind of fancy orange and um, champagne sort of things. Yeah. Thank you for the follow, Kuhn Henry as well. Welcome to the stream. Hope you're doing well. Anyway, let's get back into this. Okay, so if it's not the same as the current frame, then we need to decrease the usage count. Then when we've decreased the usage count, we can start loading it in. So first thing we do is we check is the new frame. This is current. Let's call it old and current. So old, same as old frame, is new, same as old frame. So exit. Okay, so we're going to have source frame index, and this will have old and new. New is just the one that we're actually. I'm not going to put that in there. That's just going to confuse things. Okay, so is a new frame already cached? If it is already cached, then the entry in the list will have a usage count of. Actually, it won't have it could have a usage count of 0, but what it will have is it will have an address which points to it. You need to think about this because you need to make sure that if it is cached, I think we need a cache flag as well. So it's not just a case of is the usage count non-zero, because the usage count could be 0, but it could still be cached. Oh, 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 Andy, this is your moment to shine. No, I think this is number 3, maybe. Wait, what? Well, that's blatantly completely wrong. Okay. Let me check that because that's blatantly wrong. I mean, I don't even know how it managed to get that, but I'm pretty sure that wasn't Fear Effect 2 Retro Helix. I'm pretty sure that was Tomb Raider, right? Yeah, I thought it was number 3. I just want to check, just in case that is some random kind of game that just happens to have Lara Croft in it. I don't think it is, but oh shit! You know what? Do you know what? It is. Yeah, it is that game. Go and take a look. The main character looks like Lara Croft. Amazing, amazing. Wow, yeah, the main character looks like Lara Croft. That's crazy. They obviously saw how well Tomb Raider was doing and went, right, we want a piece of that action. Let's create a character with the boobs out and just did that. Wow, that's crazy. I would never have guessed that wasn't Tomb Raider. Yeah, yeah. No, it was yeah, there it is Fear Effect. I can see the same screenshot here. No, it is. I don't know if you can see that. That's so frustrating. But look how much she looks like. I mean, she's basically Lara Croft, just yeah. That's kind of funny. That's kind of funny. Okay, cool. I thought there was a huge error there in the thing, but no. I like that everybody went Tomb Raider then. And in fact, we were just sat there debating with whether it was Tomb Raider 2 or not. And cool. That fooled everybody. You had Fear Effect. Oh, did you say Fear Effect? Oh, you did say Fear Effect as well. You did not fall for it. Well done. You just didn't put two in. Shame. Shame. Oh well done. I feel like you need points just for that. Well spotted though. I mean that because the screenshot had nothing to indicate that it wasn't Tomb Raider. It looked yeah, I mean that's really good. That's my favorite screenshot quiz so far because it was so random. Um huh? What's Acmefin? What are you on about Acmefin? All right, let's carry on with this. I'm getting distracted. Okay, so we're gonna have this is all 8 bytes being used. So 3 bytes to point to where the sprite is being fetched from. 3 bytes to show where the sprite is loaded in memory. Although this could be a pointer actually, so this could be 2 bytes. In fact, yeah, let's do that. I think 2 bytes is better here because that would just match this pointer exactly. So okay, let's put the information up here. So sprite index is bytes 0 to 2 is our fetch address. So this is our data fetch address. Then bytes 3 to 4 is our target pointer. 16-bit sprite pointer. Then bit 5 can be our usage counter. And bit 6 can be flags. And the first flag in here will be bit 0, which is whether it's cached or not. Let's actually make that bit 7, and 6 can be unused for now. And the reason I'm keeping it to a round number like this is it just makes kind of calculating where we're at a lot easier. So, okay, so is a new frame cached, i.e. is the flag set, so this is this flag here. If so, set the sprite target pointer to match and increment usage. So we would increment this by 1, and we would set the target sprite in here to point to this sprite pointer address, because this would already be set. If not, then it's not cached. So now we need to find, if not, we need to find a free sprite. Okay. And how we do that is cycle through sprites, pick first sprite with either with 0 usage and that's all it needs to be, isn't it? Yeah, we just need to find one that is not being used at all. Yeah, okay. Cycle through sprites, pick first sprite with 0 usage. All right. Then when we found the sprite, we need to wait. Hang on. This is these are actually going to be set ahead of time. So our sprite pointers are going to be calculated ahead of time, right? Because our sprite pointers are going to point to this sprite cache, and each block in the sprite cache is a separate sprite that's been unpacked. So these can be pre-calculated, which means we can do this in here. But I'm not going to do it in there because of the way that works. I'm going to instead have a in here, which is going to do that. So just put a note in here to recalculate. Oh my god, I can't even spell properly. Recalculate the pointers for cache. This should be relatively simple. This shouldn't change once they've been set up. The sprite pointers will be the same all the time. Okay, so we don't need to calculate the sprite pointer, but what we do need to do is unpack some data into that location. Actually, we kind of do need more bytes here, but we can probably store that in here. Let me think about this, actually. We can reduce the size of this down. We don't need this. This can be pre-calculated here. And doesn't even need the init. All right, cool. So let's change this. Data fetch address definitely needs to stay the same. This is unused. So let's just change that to something like that. There we go. Okay, so then here we need a pointer table. Which is this is the table that we'll use. So once we know which sprite it is, we'll use this to fill the pointer in. And then we'll have a sprite cache address table. And this table is where those pointers actually point to in memory. So these two tables will be related in that this will be 64. Sorry, this table will be 64 times the value in this table. So this will be 3 bytes. This will be 2 bytes. Okay. So in that case, what we need to do is fetch the cache address for target sprite index. And then once we've fetched the cache address, fetch the data address for compressed frame data. We should have all of these at this point, and then we should just be able to unpack the frame into the cache. And then we should be able to set the target sprite pointer. All right, I think that's everything. Oh, brave entry. Well done. Which milkshake flavor is best? Oh, yeah, I have to agree. Actually, chocolate. I don't know why. I don't know why that's there, but okay. It's banana. I do like a banana milkshake, but I just prefer chocolate. Chocolate is just so good. Okay, I think that's everything we need to do to change the sprite. And then that means if I call this routine, I should be able to change the sprite in this location here. Which means I do need to do some slight changes to the initialization list. But what I can hopefully do is you can probably hopefully see these animating if we get this working. So what I'm going to do is I'm going to start by generating these tables. So to do that, I'm going to start with Sprite cache base. And this is going to be set to a location in memory where I want these sprites to be loaded into. And that is going to be at this location here. And now I need to set do low and high here. And oops. Now the sprite cache needs to be the same size as the maximum number of sprites that we can have. If it's not the same size, then we run into the situation where it needs to be at least the same size or more. If we have a sprite cache which is smaller, then if there are 64 unique sprites on the screen, there's not going to be enough room in the cache to display them all. I'm going to run into really awkward problems. In fact, we'll probably enter some weird kind of. Well, in fact, we'll crap out at this point here when we need to find a free sprite. There won't be a free sprite, so this would fail. So let's make sure that's at least this size. We'll start with the same size. That should be enough, I think. But if we wanted to, we could increase the size of the cache, and increasing the size of the cache would mean that increasing the size of the cache would mean that we had more room to kind of to keep sprites in memory for things like that get used a lot, sort of thing. But I think we'll probably be all right with this. Have I had any more basic 10? I haven't had any actually more since then. I hope are you guys still getting on all right with that? Because the deadline is next week, and I've not seen very much. I've seen little bits from you guys, but I've not seen too much. So hopefully you guys have something. Actually, can you do another poll, Andy, or steps? And just to ask how who's going to be putting an entry in. It'd be a good idea to know how many of the people watching that is. So, um, how's in? I think he means who's in. Yeah, I mean, if it's not so restricted by this fucking basic version 10, yeah. So I'm gonna do an assembly one fairly soon. The next one's going to be a C64 challenge. I already know roughly what I'm going to do, but then after that, I'll probably do a 45 DSO2 assembly one as well. This is all kind of experimentation. The game can be as little or as much as you want it to be. It doesn't have to be amazing. The restrictions are there because of basic 10. I realize that, and I know it's not going to be easy, but hey, Emma, if you submit something that runs in basic 10 and it's part way of making a game, please submit it. Don't not submit. I will still enter you into the draw. I just want I want as many people to just kind of give it a go as possible. I'm not gonna. This isn't about who's made the best game. This is about just having a go. So, if you've got something and you've done something, just send it to me. Absolutely, it's all helpful. Do you not expect Turrican 4? Wait, what? You told me I was getting Turrican 4. Oh, damn you! But yeah, just send me anything you've got. Really, just don't. I'm not expecting anything amazing. So I set a challenge, Cyberflyer, a couple of weeks ago, 2 weeks ago now, I think, to make um, an homage to a retro game of some kind. Basically, just make a game in Commodore in Mega65 Basic, so in Basic V10. And it's been tricky. I think people have struggled with it because the basic is so broken on the ROM version that that I've kind of forced everyone to use. But um, it's more about kind of just testing things out and seeing what we can do and just familiarizing yourself with it. But there's still a week to go on it. It's not really a competition; it's a challenge. It's just if you make something, you'll get entered into the draw, and if you get into the draw. Actually, I don't have an A7 on me, but you can win one of these. But it'll be the A7 version, not the Nexus 4 version, which will allow you to run Mega65 stuff. Um, I can hear Sid's. I can see everything on my. Oh, okay, it's good. All right, cool. Yeah, I just restarted. It's OBS. OBS failed. That was weird. The sound, like, for a second, it paused and went and jittered. And then it came back, and I could see all my levels going up. But yeah. Okay, if the poll reset, there were 4. Okay, that's okay. Well, hopefully, people will send me work in progress, and anything is good enough. So I think I'll be careful if I do another basic challenge. I think I'll be careful next time. So steps that's for 10K. Good. All right, let's crack on with this then. Okay, so pointer table low. Okay, so pointer table low. Right, okay, so this is basically this address plus 64 times I. Oh, restart quiz. Yeah, good point. Oh god, yeah, I've got nothing going here now. Damn it. Right, hang on, one sec. Stupid OBS. Oh, Amiga. Okay. Okay, so I need the Sprite cache base plus 64 because the Sprite is. Oh, hang on. 64 times I times our Sprite height. Now, our Sprite heights here are. Uh, oh, shit. This is awkward, actually, because this needs to be. This needs to be calculated based on. Actually. proper memory locations. So these will be 6 apart, but there'll also be a blank sprite above it here. So they're actually 7 apart here. So this is actually 64 times 7 times I. And that gives me oh my god. Okay, so that gives me yeah, okay. So that gives me the location of the first blank space, then I need to divide it by 64 and plus 1. We'll soon know if this is right or wrong. Uh, in fact, I can test this out by putting these values into here with the old sprite data. So I'm going to copy the old sprite data in, and then use this method um, to set these values in here just to check that they're working. I think it's correct, but let's just try. So I'm going to just load in the unpack data. And then in this side here, I'm just going to set those values using that same method. So I'm going to take this, put this in here. So this is going to print the same half of each character, but it should still hopefully work. And our cache base is actually, in this case, it's not using the sprite cache, it's using this. And this would be, let's make this Sprite 2. So we're going for 0, 1, 2. We're going for this half here. And this would be the lower part, okay. Then this would be the upper part. But then we also in the middle of this, we also need to add God, this is getting confusing. Put 60 because this is the sprite height. The upper nibble of this is used for sprite height, so hopefully that should work. So let me just put that one on there. What do you mean invalid token? That's correct. Why is that invalid? I don't understand why that's an invalid token. It should be because that should be byte. That's why. Thank you. Yeah, I got it just as you said it. I've still got an error here. God damn the MNK, but I've still not done them. Oh, okay. I'm not sure what it's doing there. Hang on. Okay, so what this would be is it should be. Let's try and set the values manually and then see if it matches what I'm expecting. So this would be 62. I think I'm getting this wrong here. I think that's what I'm getting wrong. Let me just try this out, this value out. Once I work this out, then I can figure it out on that side. Sprite looks awesome. Yeah, it is. You've not seen. Let me show you the concept art as well for the level. I was showing this before. You might not have seen. You might not have been around when I was showing it. So this is what the level kind of artwork is roughly going to look like. This is just concept art. So this is just kind of sketched out in some kind of paint package. I'm not sure what it's used in, but it's got the main character in there. But you can see it. It's going to be a nice theme anyway. It's going to be really cool. Really looking forward to it. Okay, so I've got a sprite in there, but I don't think it's quite the right. There seems to be some jittery stuff going on above its head. So if I was to set that to 0, 1, that should just be one half of the character. Oh no, it has to have the space in at the top, I think. Maybe that's the problem here. We set that to 0. Yes, it has to include the space, so the +1 is unnecessary, I think. See, that's right. There's no flickering on this. It's all the same half. Okay. So in that case, what I need to do is get rid of the +1. So don't need that bit there. So then is this bit right? So the address becomes. So maybe the easiest way to do this is take the original value like that. And then add our sprite index. So our sprite would be sprite 2. But we're timesing that by 7 because there's 7 characters in each sprite. There's a 6 that make up the sprite, and then the 1 blank before it. That makes this way neater than it is at the moment. So it actually becomes the same here. But we have to have the +60, which is this bit here. This +60 is because this upper nibble describes how high the sprite is, which is used for the renderer to work out how high the sprite is. Which is another reason it's good, because the change sprite will get rid of the need to know that information. So right, okay, so hopefully this now will display something similar. Come on, load. Okay, no, it's freaking out here for some reason. Okay, let's have a look at this. Let's put this into a calculator. It's going to get rid of that a second. That's going to get really distracting. What am I doing wrong here? So I don't understand. Okay. Let's change these to hexadecimal. Is it that is being added at the wrong time? Maybe. I bet that's what it is actually. Let's take a look. So in hex, 8,000 divided by 40 gives me 200, right? Oh wait. Oh yeah, plus 2 times 7, so it's plus 0. Okay. Which means if we just take the upper bite of that, we get 2, which makes this 62. So this should be 62 according to that. Which means this would be 0e. which means if I do the same down here again, 62 0E. This is what I should be seeing. So if I do this the same again, should see the same thing. I have a funny feeling I'm not going to. Building an engine that uses the Mega65 hardware specifically. Yeah, exactly. So this engine is used. See, there's a problem with the calculation somewhere. It's probably this plus 60 here. Probably what's wrong. Maybe you want to use a clean SD kind of ROM that doesn't wait for drive. It's I think the ROM I've got is already. Oh no, it does wait for the drive. To be honest, it doesn't bother me that much. It's a couple of seconds. It's fine, but maybe I can kind of change that up at some point. The SD card has an image on it that has the assets on it, so I do kind of need those. But yeah, to answer Junkyard Tuning, this is an engine specifically for the Mega65. So targeting the raster rewrite buffer stuff so that I can get the most out of the graphics engine and not have to use just boot double speed or so. Okay, I might try that out actually at some point. It's probably a good idea. Okay, so I think this is wrong. I think this is failing because this value is not being added. I think this is working at the upper bounds of this entire thing rather than just this. Not that it shouldn't matter. Why is that not 60? Well, I don't get it. Why is that not 62? Let's get rid of that. Why is that not 62? Doesn't make any sense. Yeah, this is it's written in ASM. It looks kind of a bit more high level than ASM because I'm using Kick Assembler, which does have a lot of things which make it a bit easier for me to do certain things in it. So, oh, hang on, this is taking the upper byte and then adding this on. So actually, if I did, no, that's right. That's what it should be doing. Do I need to do that? Is it that stupid? I mean, I hate having to do it like this, but that fixes it. It's not going to fix it with the wrong number of brackets in, but yeah. Bit of outrun. Hey, there we go. Yeah, it's this. This was actually looking at the whole thing first. So it treats this as all one thing. So actually this isn't a normal operator in that it just evaluates the entire thing and then takes the upper byte of it. So I have to make sure that 60 becomes the upper byte by making it 6,000 instead. Okay, that's fine. Okay, so let's port that over to here. So in that case, what do we need to do? We need a Sprite cache base divided by 40. Let's put that in its own section here, like that. And then this becomes I times 7, or 7 times I, just to make that a bit easier to deal with. Which means that's not needed and that's not needed. Cool. And that needs the plus 6,000 on because all these sprites are 6 high. So I'm treating every sprite as 6 high, even if it's not 6 high. So a smaller sprite would still be treated like a 6 high sprite, um, but it would just have a load of blank zeros in it. Okay, cool. So that's that area finally done. Let's get rid of the crappy bits. Let's keep them like that. All right, cool. The core architecture is 45GSO2, which is a custom chip for the Mega65. It's an FPGA implementation. The 45GSO2 is based on the 65CE02, which in turn is based on the 6502. So it's just a kind of it's almost like a third generation of the 6502. It has some additional stuff like 32-bit addressing in it, an extra register. It has a Z register in it. It's mostly 65C02, but it does have some 32-bit addressing modes which aren't in the 65C02. So, and it uses the VIC4 chip, which is an imagining of what the next implementation of the VIC chip would be. It's much closer to the Commodore 64 than it is to the Commodore 65. I think the VIC4 implementation. The C65 tends to use bit planes and stuff, whereas this still uses character modes, and it's much better for it. For instance, all these sprites that you can see on screen are not sprites; they're characters. This is all just done with basically software sprite systems, or rather than hardware sprites. I'm not using any hardware sprites at all to do what you see here, and everything here is just done with a basically without bit planes, just using character mode. And a special feature of the VIC4 called the raster rewrite buffer, which allows you to superimpose multiple layers on top of each other without alpha transparency as well. All using character mode, not using any bit planes or anything. So it's very cool, very cool. And everybody that's used it so far, every coder that I know that's used it is loving it. So it's really good. All right. Right, so annoyingly, that's that table. It took long enough, but we've got that table in there. Let's import this in while I remember. Sprite cache.asm. Okay, let's import that up here. Oh, have I called it ASM? I should have called it .s. Let me rename that. Just save it, close it. I'm trying to keep S for Mega65 and ASM for Commodore 64. Okay, so the cache address table is kind of similar to this top table, except it's going to have 3 values in. So I'm just going to call them 0, 1, and 2, rather than high, low, and mid, or whatever I'd call them. But basically, it's the same kind of table, but instead of pointer addresses, it's going to have direct cache addresses. So the reason I'm using a separate table rather than calculate from this is because this will be a lot quicker when I want to do the caching, when I want to do this kind of on the fly. So, hey Paul, all the coders are working in assembly at this any point. All right, yeah, no, as Paul says, there are C compilers that work for it as well. Kick C apparently is very good as well. I kind of want to. I'm kind of tempted to do something just to test that out, but apparently it's really good. It'd be nice to write a kind of high level raster rewrite buffer engine in C, so you can create a kind of a kind of graphical framework, kind of like I don't know. I'm trying to think of some offhand now. I can't even think of any. But you know, you could create some nice libraries that would allow you to treat raster buffer layers as just images and move them around and stuff. It could be a very powerful engine if done right. Rather slow to compile. Yeah, I imagine actually. Oh, thanks for the bits, Amok. Cheers, man. How are you getting on with your cartridges? Have you played much of them yet? Yeah. So does each sprite frame define need an empty 8 pixel? Yes, it does. So the raster rewrite buffer works is when you go to draw something in the raster rewrite buffer, um, everything is drawn on rows, right? You can't draw something halfway down a row. So in order to be able to move things in the Y, which you can see here in this in the little demo in the corner, in order to move things in the Y position, the only way you can do this is by offsetting the data. So Paul has added a couple of bits in one of the registers. I can't remember which one it is, that allows you to say when you're drawing this row, when you're drawing this raster rewrite buffer layer, fetch the data from three rows back. So by having a blank row up here, let me just set a canvas size here. Oh, thanks, Mega64. Thank you for the bits as well, Andy Magic Knight. Cheers. Thanks to everybody that's bought the cups and the mugs, sorry, and the t-shirts and the sweatshirts and stuff. It's all really good. It all goes towards paying for these as well. So we will have more of these to give away soon. So yeah, not if you're drawing directly on a row, you would fetch the data from this point here. Let me zoom in. You'd fetch the data from this point here, and the things would draw, and it'd be aligned perfectly on the character grid. But if you want to move things in the Y, the way you do it is you just say, okay, fetch from here instead. Fetch from a little way back, and has the effect of pushing the sprite down a couple of rows. So you need a 8 pixels above it and 8 pixels below it. But if you can just line all the sprites up in memory so that they actually share the top and bottom sections, then all you need is one gap between each one, and then one gap at the end and one gap at the beginning, and that does the job. So uh, they looked normal. They did look normal. I kind of want to get one now as well. I haven't tried the cups yet, so I do want to get one because apparently they're quite big. So uh, which is kind of nice. So yeah, that's what that extra piece is about. And one of the advantages of the compression method that we're using is we don't have to think about that area at all. What we do is we just compress the data as it is, and then we generate that area on the fly as we need it. In fact, we don't even generate it on the fly; it's just here. Our cache table is going to point to the area just after the first 8 rows, so we actually end up with we end up with that gap automatically handled. We don't have to do anything about it, and as long as that area is clear to begin with, which we can do with a DMA, we can use a DMA job to clear it, which is probably what I'll need to do because this area is going to be full of ROM data. Then we don't even have to bother kind of writing to those bits. They're always just going to be clear. So yeah, pre-allocated exactly. Uh, oh, it takes 3 shots from the coffee machine. Ah, okay, yes, I need that because the mug I have at the moment takes 2, and if I put 2, it's right at the top, like right to the very top of the to the mug. So if it can fit 3 in it, that's pretty awesome. Oh, I'm gonna order one of them. I'm gonna grab one of them now. Actually, oh, actually, I wonder. I wonder. Hang on. 4 if no. Yeah, I don't have milk at all. Hey, Chromos. I hope you're doing well. Welcome to the stream. Uh, oh, oh, I can get backpacks, snapback caps, and packable jackets as well. Okay, I didn't know that. Why? How come I'm the only one that can get them though? That's what I don't understand. Oh shit! I need to film. All right, I'm not going to do that now because I've got the keyboard on. You'll see my credit card details. So I'm not going to do that now. Interesting though. I can get backpacks as well. Might have to look into that. Okay. So let's work out these addresses. Okay. So now we don't need to. The cache base is going to stay the same. Don't need to divide it by 40 anymore. Um, but now what I need to do is I need to add. This is where the 64 times 7 comes in times I. Right. No, this bit is the bit that works out exactly where we are in the memory address. But I want to also be one ahead. So I'm just going to be ahead of the space. And the reason I want to be ahead of the space is because I want to use this to actually to know where to write the data to. And because we don't need the space, it would be annoying if I had to keep adding 64 to this every time in this block here. So I'm going to do that. Now, I think here that will give me the low byte, I think. But then on this last one, this is going to have to be something like that to get this bit here. I think that is right. I mean, I tell you what, I'm gonna just because I know this is going to be 24-bit. I'm going to do this here. Oops, fucking hell, what have I done there? Oh god, that one. There we go. Just to ensure that that one is just that middle byte rather than all of them. Okay, so that's quite a lot. I mean, this is going to take up 320 bytes just for these tables, but should speed up this stuff quite a bit. So, oh, what the hell is that? Oh, is this? This is. Oh, I know what it is. I'm going to say at the end. It's Aussie Games. It's got Sydney Opera House in the background. Yeah, I don't know. Call yourself C64 fans. You don't even know Aussie Games. Quick check says it's around 426 mil. Well, that's okay. So how big is the other one then? Normal mug. Hmm. I'm the ST fan. Yeah, the only one in the entire history of the ST. You're an Aussie and you don't know it. Oh, okay. Maybe it's just me that played that then. Apparently, I'm the Aussie Games fan. I wasn't even a fan. I just know it. Okay, cool. So we've got the table set up now. So now we can actually go through this stuff here. Okay, so fetch source frame from sprite index. So we have a sprite index here. This is where we want to target from source from sprite source frame index. Oh, sprite index data. Yeah. So this. Okay. So we need another thing in here, which is going to be. This is our sprite sprite index, and this points to the thing that we set up in here. So where was it? 7C100. But again, this could be anywhere, but I'm going to put it at 7C100 for now. So the first thing we need to do really in here is we need to set up a couple of addresses in zero page that we can use to do these 32-bit indexing here. Now I'm gonna do it in the init to begin with because I think the init can set the majority of this up, and then in here we only need to reset certain things. Actually, no, let's do it all in here and see how slow it is, and then once we know how slow it is, we can see if we need to move it. I think that's probably the best way of doing this. Okay, so in that case, we need some zero page locations. So let's we're still using very little zero page actually, so let's just create some new areas. So what have we got? We've got sprite index. Let's call it cache index. Thank you for the purchase. Cape Apocalypse, appreciated. Cheers. Enjoy the mug. I forgot I put that in. I need to shorten the alert though, because it tried to play it a second time. I don't know if anybody recognized the music that the alert was based on. So we're going to use D words for these because they could be anywhere in memory, but we're gonna even though they're this one is in lower RAM at the moment, we're gonna use up RAM for it. So sprite cache fetch. Oh, and another mug as well. GHAF. Thank you very much. You've been spiral mugged and you're happy about it. Cheers. I need to change the alert slightly. It's a bit too. Well, first of all, it sounds quiet, but also I need to make it a bit shorter. So it's looping. It shouldn't. But cheers, guys. Cheers, guys. Enjoy the mugs. Spiral cat. See, I'm seeing the word sprite and thinking spiral now. God damn it. Arkanoid, yes. Arkanoid interlude, indeed. Yeah. Do you know, weirdly, I don't know what I have we played this song before? Have we played Tubular Bells on here before? Because weirdly, last night I was thinking about the album Tubular Bells and how cool it is. And this was going around my head, so it's kind of weird that I haven't. Yeah, maybe that's where. Maybe my subconscious has picked up that it's been played, and I kind of. Yeah, it reminds me of The Exorcist as well. I mean, how can it not? That's it's kind of its job, isn't it? Now. Okay, so we need a fetch address, and then we need a target address as well. So catch target. So we need to set these three addresses up. Now this could be quite. Actually, it's not going to be that slow, is it? It says one of the addresses is always going to be 0, which is the top half of this, and these are all 0 page anyway, right? So they're going to be fairly quick on the cycles. So the third byte is always going to be 0. That's never going to change, which is why it might help to have this pre kind of set in an initialization function here to save those. But then the rest of these are based on the values that come from here. Target, we don't know yet. That will come from here. Fetch will come from here. But cache index, we do need to know. So we do need to know this one. Okay, so let's just put some notes in here what we're doing. So init highest byte D words. Okay, so we need to grab the sprite index location. So the easiest way to do this is going to be to work out what the high byte is first and add that to this value here. So we can actually grab this value and this value and put them in. So let's do that now. So this here we are calculating sprite index. So we're going to load. Okay, yeah. Trouble with tribbles. Oh man, trouble with tribbles. The Tribble episode is one of the best episodes of Deep Space Nine as well. I'm saying it now. I just think it is. Just because it's got such awesome crossover with the original series. It just works brilliantly. I think they did an amazing job of combining everything together and making everybody look like they're in the same episode. It's just so well done. So well done. So here what we're doing is we're taking the middle and the upper bite. Now the upper bite here is not going to change, or it shouldn't do anyway. I mean, you could potentially have the sprite index in a weird place, but we're not going to do that here. But this byte here does need to change, because this isn't just going to be a 256 byte table, because then that would mean we'd only have 32 sprites. This potentially could be much, much, much bigger. So the old Klingons were funny, yeah, and he said he didn't want to talk about it. Yeah. Oh god, yeah. Um, okay, so here we need to target sprite index. Okay, so target sprite index is which one we're filling in here. Source frame index is which frame number we want. So this is the one we need. So we need to transfer this to the accumulator, and we need to times this by 8. Uh, Actually, the easiest way to do this is probably going to be, I'm going to put a temp byte in here, sprite cache temp. Uh, what I'm going to do is I'm going to store that at, where's that? Come on, okay. I'm going to store that there, and I'm going to load the accumulate with 0. Then what I'm going to do is I'm going to shift. Hang on, there's got to be an easier way of doing this. Oh yeah, why am I times about? I need to divide by 8. That's what I need to do. God damn it, I was right the first time. Right, I'm going to leave that there because I might need it. But so divide by 8. So I need to half it. So shifting to the right. So I'm going to shift that to the right 3 times. That's going to divide the y by 8, which is going to leave us with a value which gets added to this for our upper area here, which means we can just clear, add, and there we go. So now we've got a sprite index. So again, I'm going to transfer y to the accumulator again, but this time I'm going to go the other way and times it by 8, and this is going to mean that we end up with the offset that we need. So this will be why is that? Oh, why is that not picking up? Hang on. There we go. So now the Z index contains our lookup for this. So now we should be able to fetch some data from the sprite index. So this is the source frame. So now we can do this. We can do Actually, would this just be easier to add? This is probably just going to be easier to just add this to this value here. Oh, thank you. Thank you, Roka. Let me turn that overlay off. I don't need that at the moment, so let me just turn it off. Okay, so actually, I think it's probably going to be easier to add it to this because that means we always know that 0 will be the base of our sprite index. So yeah, let's do that one. Okay. So we're going to keep that one here. But then this one here, I'm going to use. So as long as it's 0 aligned, it should be fine. And I think it will always be 0 aligned. So I'm not going to bother, because otherwise what I'd have to do is I'd have to push the processor stack here. In fact, let's just do that. That's not gonna cause too many extra problems. So let's just do that. Hey Gildan, I always sub when you hear some. Cool. Cheers for the sub, appreciated. So the Mega65 has 4 SIDs. Yes, it does. 4 SIDs, 4-channel DMA audio sample player, and an OPL V2 as well, which is not implemented yet, I believe, but should be coming at some point. It's a beast. It's a beast of a machine for both, for graphics, for everything really. It's an absolute beast. Um, so yeah, I mean, you can use what 12 channels of SID music plus, is it 4? I think the OPL V2 has. Or am I thinking it might be more actually? Hang on, PLV2 has. Uh, can't see how many it's got, but it's got quite a lot. But it was used in the old sound blasters, and I think it was sound blaster. It was one of the old chips anyway. You can get better bass response than SIDS using the OPL. Adlib, yeah, that's the one. Adlib. I was watching a girl with big breasts, so I came here to see Sean's breasts. There you go. I mean, they're big. They're pretty big. Yeah. OPL2. Yeah, that's the one. It was in the Sound Blaster as well. I thought it was in the Sound Blaster. It's what they use for a lot of arcade machines, and it does have really good kind of classic MIDI sounds in as well. So, Creatures 3. Yeah, I'm deliberately not showing you the bottom where it says Creatures 3 coming and then the date. So, sneaky. Okay, so this should do the full edition of that value. Don't need to update this. We don't need to worry about crossing those page boundaries. These should be pretty quick. Single byte instructions are generally pretty fast. I think they're 1 cycles. I don't know about pushing processor status onto the stack and pulling it back, but I think it probably should be about the same. And this gives us the sprite index is now properly in here. So now we have we know exactly where to grab this information. So the source frame in that case is, or the source anyway, is from data fetch address. Okay, so that's the first 3 bytes in here. Let's put 0 page over this side a second. So that is, let's get rid of that. We don't need that anymore. I probably was going to keep it around, but worried that I might not. Just make some creatures like, oh god, that would be such a troll, wouldn't it? Yeah. The crazy thing is that a Creatures 3 t-shirt even without the creatures 3 game, would probably sell like crazy, absolute crazy. Okay, so let's have a look. So now we need to set the fetch address up. Oh, fetch the source frame. So we're doing a check here. So we're checking source frame. What did I say the source frame would be? Oh, is it the same? Okay, so oh, I don't know, because this is not the source frame, is it? We have data fetch address, and then the cache points to these. Wait, what's going on here? No, 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 no. This is wrong, isn't it? Okay. Oh, from the source frame. Okay. So we grab a source frame, which could be like 1 to 256, and we need to check, is that the same value that we've already got in here? So is this value here in our target sprite the same as what we've already got in here? So that's basically grabbing these values and checking it against what we've already got. Okay. So so that's a little bit different. Okay, so now what we need to do is put the RRB sprites on this side. We need to grab these values in here. So let's just move that down there. That's wrong. Okay, so load RRB sprites dot data dot pointer low comma x, because x has our target sprite index, and we need to compare that with create a label here called not same. We need to compare that with the value in this table here. So this is pointer table. Is that right? Hang on. See you later, Paul. Thanks for joining. Let me think about this. Let's get some more alcohol in me. Okay, my new favorite is rosé wine and Fanta orange. It's very, very good. And I've run out of Fanta, but I know I have a can over here. I have a pack of. So I need to compare the sprite that I'm targeting to see if it matches the source frame that I already have. Yeah, which is this one here. I just need to see, is it the same as this? Is that right? My head's not getting around this quite. Hang on. So, hang on. Right. So I have a table. The table has a list of the fetch addresses for all the sprites, and then we have, and because they're pre-calculated, the positions, the pointers for each sprite are pointed in the same location. So what do we need to know? We need to know, is the sprite that I'm about to display the same as what's already there? No, this is different. All right, so actually this bit I've not thought about this properly. This bit I need to come and revisit. So for now, I'm just going to leave that and put to do. It doesn't really matter. It just means that it's gonna refetch every time. But I need to work out how to determine how to actually do this bit, because it's not the straightforward thing I thought it was. Because you can't just check whether these values match, because these are going to be the same for this sprite all the time. The same cache place is going to have the same sprite, but the cache may be fetched from somewhere different, and we don't have the fetch address anywhere other than in here. And that isn't stored anywhere in this sprite, so the sprite doesn't know where it's come from, it just knows what it is. So that's going to be oh my god, you got mod check for being racist against white people. Yeah, you did. Oh wow, amazing. Amazing. That's brilliant. Okay, so I think for now I'm going to leave this. It's not gonna break the routine. This is an optimization, so let's put a note in here to say that this is optimization, because without this it's still going to work. It just means it's always going to fetch. But we need a way for a sprite to know where it came from, so that the next time we go to change it, it can say, "Oh, I've already pulled the sprite from there. I'm the same thing." So um, we don't need that. So decrease old frames usage count. Okay, so here we need to look at the value in the index here and decrease its the current value in here and decrease its usage count. Oh wait, no, this isn't going to work either. Hang on, this is all wrong. This is all wrong. Oh no, sprite index. No, that's cool. Yeah, but we still don't know where this sprite has come, where the current sprite has come from. So given a sprite in here, we don't know where the sprite has come from. So this needs some extra link into this area here. So the usage count is going to break as well. Oh fuck. Okay. Okay. To think about this. Um. So I know. I want to draw a sprite. I say I want to draw a sprite frame 0 into sprite 0. I need to check if sprite 0 frame 0 is already being displayed somewhere, which is what this is. And that's what sprite index. Sprite index points to the cache data. This is cache data. So this says for every sprite we have in the cache, this is how many times it's been used, whether or not whether why does it say cached and not oh right, yeah, because for every possible frame, this is all frames actually, this is where the frame is available from, how many times it's currently being used, whether or not it's currently being cached. So we can't do this because that's if so set sprite target pointer to match. So that would be in here. So we'd need two. This is where I'm getting mixed up between these. which is cache data, and this, which is frame data. So let me put a note in to say that. Okay, so this is cache data tables, and this is frame sprite index. So this is for every possible frame. We have a fetch address, a usage count, and then some other details in here. So that means, given can ignore that, decrease old frames usage count. Okay, so that means we do need to have something in here which points to a frame index. Okay, so let's add that in here then. So frame index low, frame index high. Because we only need 2 bytes to represent anything in our frame index in this list here. Again, I'm not gonna deal with this right away. But we might need another. Shit, we are going to need another one, aren't we? This is going to grow in size really quickly, you know. Okay, no, it's fine. Let's get this in. Let's get this in. So Sprite cache, old index. So yeah, this is probably going to be best initialized somewhere else because this is never going to change. This, on the other hand, will be different. So we've got the Sprite in the new Sprite index and the Sprite old index as well. So the Sprite old index is a link into this frame data here, but for the sprite that's currently in place. Now we get that value by taking not the source frame. Oh, maybe we can just store this. Yeah, let's do this sneakily. Okay, so this would be a lot less then. In that case, we would grab. Okay, I've got it now. So we grab that. We grab data. We grab frame index low and store that in here. Don't need that in that case, and this is comma x because it's a sprite that we're putting it in, and then that would be like so. High. Cool. All right. So now we've got our old index and we've got our new index. So we can actually do this here. Okay. So is the new index the same as the old frame? Okay. So how do we check that? Okay. So we need to check these values against each other. If these values match, then it's the same, because what we're going to do is we're going to push this value into here as well. So let's put this here. Set the target sprite pointer. Save the frame index, which is this bit here. So we don't need to compare the top one because the top one probably isn't going to change at all here. In fact, it would probably be sensible to do this and make sure that those sprite indexes are also using them. So now we're forcing this to be on the same page. But we should, in theory, just be able to compare that directly to this value here. So if this is, actually, let's do it here. So we're going to compare the upper byte first. Compare that to. This sounds like a creatures level. Oh, it's red. That's why. Steve Rowlands. It's got that. It's got that funky. He likes these funky bass lines and beats. Very recognizable as Steve, definitely. Okay, so what that means is now we can check here. So if the upper byte is not the same, then obviously we skip, and then we can check the lower byte. And if that's not not the same, we can skip. Cool. If it is the same, we just exit. We don't need to do anything at this point. Cool. So now we've actually filled that in. That's great. All right. Now decrease old frame usage count. Okay, so now we actually have this in here. We should, in theory, be able to do this. Oh, actually, do we have that? Let me just check. Still getting used to these new addressing modes and whether or not they have all the things in. I bet it doesn't, you know. Seems like a long shot that this would be included. Yeah, it's not. All right, cool. Okay, and then that would need to be whatever our usage counter is. Our usage counter is like 3. Is the new frame already cached? Okay, so now we need to just check. So we're decreasing the old frame because we're going to replace it. So now we need to check the new frame to see if it's cached. And that is bit 7, bit 0 of byte 7. So this should be Sprite cache index like that. And now we should be able to test that against. If so, set Sprite target pointer to match and increment usage. If not, we need to find a new Sprite usage. Okay, so if it's not, we'll jump to find Sprite, which is going to be this bit here. How much does a hipster weigh on Instagram? What the? Is it hipster now to use Instagram? I tried using Instagram for a little while. I was posting pictures of computers I'd built and stuff, and it was kind of cool. I got a few fairly decent size hits on some stuff, but it seemed like an awful lot of work to take these fancy looking pictures, um, and I don't know. It just wasn't my thing at all. I think I'm showing my age there. Okay, so if the sprite is already there, then do I need to do? Okay, so I need to set the sprite target pointer to match. So that means I need to take the data in here and set it to be the same value as can be found in the current cache index at byte. No, in pointer table, sorry, table low. And that is doing a lot of this in my head, and I'm hoping this is all okay because this is getting kind of confusing now. Thank you very much for the follow, Chubbe or Raka. Chub, I'll call you Chub. Thank you, thank you for the follow, Chub. Appreciated very much. Thank you. Okay, I think that's right. I think it's just a simple case of copying it from there into this one. Because what we're doing there is we're saying, okay, set our target pointer to be the one for this particular sprite. Oh, is the new frame already cached? Oh yeah, okay. Oh, but this might not be this. This is not going to be this, is it? This is going to be something else. Ah, okay, okay. So we need a cache index in here. So that means because that means we need to set. Okay, so we set fetch a cache address, unpack the frame into go set the target sprite parameter. We also need to set the cache index here, which we can do as soon as we've done this. Actually, okay. Thank you very much for the resource 6502 kebab. Very much appreciated. Cheers. This is actually really confusing me. I'll get there though. I know this is the right way to do this, and this cache will work really well when it's working. But in the meantime, I think I'm confusing myself. It's probably all the alcohol that's I'm consuming, which probably is not helping very much. But whatever. I'm not going to do without the alcohol. Shannon, am I an angry drunk? No, no, far from it. I'm one of those annoying drunks that hugs you all the time and tells everybody that I love them and close one eye and like that all night. Far from an angry drunk. Proper haircut, yeah. I had my hair cut. That one there. Had that one cut. That's such a dad joke, isn't it? I had my hair cut. Okay, so if I set that sprite to be pointing to an existing cache location, do I need to do anything else? Yes, I do need to set the frame index high and low. I've already set the pointer. So I'm going to change this to jump to set frame index. Which is going to be this bit here. If you're not a dad and you do dad jokes, they call it a faux pas. I do. I am a dad, so I think I'm allowed. Oh, I fell for it. Chromas, I fell for it. Yeah. I'm annoyed. I'm annoyed I didn't get that. Oh, damn it. I'm annoyed with myself. The only angry I get when I'm drunk is with myself, to be honest. Are you check annoyed? Oh, very good. Very good. Okay, so I need to save the frame index. This is going to be pretty simple because that's basically these two values here. Oh, hang on. Yeah, those two values need to be saved. So sorry, these two values, 0 and 1, need to go into frame index low and high. So oops. Frame. Of course it's capital. Why wouldn't it be? And that's just going to ensure that the next time we come in here, we can check. So this was the missing link that we didn't have. What did one nut say as he chased another nut? Strawberry and lime. I'd say I still got a bit of that. I should finish this can off as well. A bit of strawberry and lime. I tell you what, drinking that wine with the Fanta is really it's really helping me drink it. Because I have been struggling with my wine recently, and I don't know why. But two, it's the perfect kind of. It tastes delicious, and I'm not getting too drunk too quickly. So I think what I needed was more mixers in my alcohol. It works really well. I mean, the wine's nice, which probably helps. I mean, I'm guessing if you put like a Lambrini with Fanta, it would taste disgusting. But a decent wine and it tastes pretty good. So okay, so now I've got it so that if we're already using a Sprite, then it's going to set it and come to here. Otherwise, we're down to this last section, which is where we just need to find the free Sprite. So the way I'm going to do this, first of all, is I'm going to turn off the packing, and we're just going to make sure that the system works. So I'm going to turn off the Sprite packing in here, and just return the data as it is. So this is not packed data at all. It's just going to be the full data, and then that means what I'm going to do in this area here is when we go to unpack the frame data, it's going to call another function, and that could possibly be due to something in here. In fact, let's make a byte here, and this is the frame compression type. So this will allow us to have each frame compressed differently. So some stuff could be compressed really heavily, and some stuff could have no compression at all. I am mixing. No, I am mixing orange Fanta, and rosé wine, Mega65 rosé wine, the best wine in the world. Yeah, that's what it reminds me of. I did do one with cherry Coke as well, but the Fanta was the better one in my opinion. The Fanta had the nicer flavor, I think. Thank you for the follow, Urban Protagonist. I like that name. It sounds like Urban Protagonist sounds like a kind of, I don't know, like an album name or a band name or something. I like it. It's cool. How do you sleep drinking all that? I don't sleep anyway. Honestly, drinking the alcohol is probably the only time I actually, yeah, I pass out. My sleep is terrible. I am averaging maybe 4 hours a night through the week. Sometimes less, sometimes a little bit more, but probably on average about 4 hours a night. I just can't sleep at all. It's this pandemic stuff. I just bought an exercise bike to try and A, lose a little bit of weight, and B, knock myself out a little bit before I go to bed. So you need to start a pound, yeah. I don't get away with 4 hours though. That's the thing. I'm absolutely shattered. This is why I struggle to do stuff outside of the streams. The streams keep me going. If it wasn't for the streams, I'd just be in bed the whole time. Yeah. What tends to happen is by Thursday, Friday, I tend to get really tired around lunchtime, and I'll go and have a little nap. Um, and that's it's almost definitely going to happen on a Friday, and sometimes happens on a Thursday as well. And then on Saturday, I kind of catch up. Again, I fall asleep really late, but I tend to get up quite late on a Saturday, so I tend to get around about midday because I don't sleep till like 6 a.m. or so 5 or 6 a.m. So um, I don't nap. Yeah, it's really really bad. And being off work has caused a bit of fuck. Yeah, I mean I am working, but it's that not going, not going into the office is such a difference because it was, it's only a little bit of walking. I just have to walk to the station and walk back from the station. It's like a 20-minute walk, 25-minute walk. Um, but it's enough to kind of to just get me off my feet and make me use some energy, and it's kind of killing me. Where are you at so far in tonight's coding station? Is it working? Not quite. No, there's quite a lot to get my wrap my head around, which is why I've just turned the run length and coding off now, because we can work this bit out hopefully now, to work without the run length encoding. So we need to find a free sprite. Okay, so this bit should be pretty easy. So cycle through the sprites to find the first with 0 usage. Oh wait, hang on. This is cache data now. The usage counter is not going to be useful here. Shit. All right. Oh fuck. How am I going to do this then? See, this is a problem as well now, right? Because so I've got two sets of data, right? I've got my cache, which is my 64 sprites that are being displayed on the screen. And then there is the frame data, which is an index of all the frames and if they're being used or not. But this cache data down here has nothing to say I am being used or I'm not being used. So actually, what I need to do is I need another table, which is our cache usage, and this should be the one that actually has this. It shouldn't be this value here that gets changed. It should be this one here that gets changed. And this cache index should be what we use to grab this value. Okay, so I'm going to make that unused. Actually, I'm going to nudge things back a little bit here. So let's do 3, 4, 5 to 6 like that. It's kind of looking like I could probably fit this into 4. No, I can't actually. Anyway, so this just needs to be a table, starts with zeros like that. And then in here, see here's the problem, right? Usage count is not this value. We need to grab this value from the index here, and then transfer that into here. So that grabs our cache index, and then we need to grab cache usage, common said. Right, there we go. Is a new frame already cached? Okay, and then this would be, so set sprite pointer to point to it. So this was 4. So this would be 3 now. Okay. So this is our cache index. Yes. And then we grab that. Okay. Right. So now we can cycle through. So what we're cycling through here is cache usage, comma Z. And what I'm looking for here is as soon as that value is 0, then I can jump to this position here and set the cache index. So as soon as that is equal, we go to set cache index. Now this should never fail. So what I'm going to do is I'm going to put a break in here that if it hits it, it's just going to do a border color cycle and just repeat, so we can see if there's any problems here. So let's do this backwards through this list. So let's go from max RRB sprites -1. Let's decrease that and branch if not equal to here. I just need to check that those loads do have a Z index on it. I can't remember if they work quite the same. I might have to change the indexing on those, because I know there's some weird things with the Z index. It doesn't work exactly like with the Z register, so it doesn't work exactly like other ones. Hang on, that's not 45. Ah, there we go. There we go. Yeah, see, there's no absolute comma Z. There's only indirect comma Z. So I can't do that basically, which means I can't do that here either. So what I'm instead going to do is I'm going to transfer this to the Y register. But first of all, I'm going to push the Y register onto the stack, and then pull it back here again. So this is one of the cool things about the 45GSO2 is you can, and 65CO2 as well, is you can push registers directly onto the stack. You don't have to push them through the accumulator first. So it makes it very easy to kind of, the stack is used a lot more, I would say. Oh, what is that game? That looks really familiar. Billy Bob's Rodent Rampage. Good guess. Good guess. Chrono Cross. Ah, god damn it. Yes, I do know that game. I thought I recognized it. It definitely looked familiar. So we're going to do the same again here. We're going to push the Y register. Now, the reason I actually do I need to push the Y, because the Y is the source frame, and I probably don't need that anymore at this point. So I'm going to get rid of it here because I don't think it's actually needed. I'll leave the space, but don't think we really need it at that point. Thank you for the follow, Necronomicon ZXS3. That's a long name, long ass name. Welcome to the stream. How you doing, Mark? Tomb Raider game. Yeah, I liked the I like Tomb Raider for kind of adventure stuff. I kind of like Crash Bandicoot as well. Crash Bandicoot was very cool. And the racing games as well. Rage Racer, I absolutely loved. I absolutely adored Rage Racer. And the thing is, I played it on an NTSC version on a PAL chipped PAL machine. So I was played it in black and white for ages, and I didn't realize just how colorful you could make it. It was incredible because you could draw on your cars. You could design stuff on your cars. And so I had all these like crazy cars that I drawn. I didn't know what they looked like at all. Oh yeah, Tekken and Soul Blade as well. Tekken 2 and Soul Blade, very good as well. They were the fighting games of choice. FIFA games were pretty good as well. That was when FIFA was still relatively okay. Of course, nowadays it's not. It's kind of a bit shit nowadays. What am I doing? Official the Gamer Cat. What am I doing? Who knows? Who knows anymore? No, I'm doing assembly for the Mega65. So it's kind of a sequel to the Commodore 65 that never came out. So it's a machine that a group of people at the Museum of Electronic Games and some I can never remember the full name of the museum. They've made an FPGA machine based on the Commodore 65. It's a Commodore 65, but with extra stuff. And I'm writing stuff for that now, writing a game engine for it. So what we're going to do, we're going to do this here. This is like a catch. Should not hit this ever. That's not to say we won't, but we shouldn't hit this. So I'm just going to do this here. Hopefully we never hit this point. If we do, and the border starts flashing, then we know we're in a got a problem. So I'll tell you what else I liked on the PlayStation. It was a pool game called Pool Shark. It was one of those games that whenever you had friends around, it just went on every time. You just put it on because it was a nice, easy game to kind of relax and play to. It was very good. Good luck because this takes a long time. Yeah, it does. This has been a fairly complicated piece of code actually. Oh, and Wipeout, yes, of course. Wipeout was one of the first things I saw on the PlayStation, and I couldn't believe what I was seeing. Yeah, 2097 definitely was better. It was more forgiving, I think. 2097, like on 2097, you learned to kind of scrape against walls and with the air brakes and stuff. But on the first Wipeout, it was really unforgiving. If you hit the wall, that was it. Didn't matter how little you scraped it or not. It was very, very punishing. But I remember it being amazing. But I also at the time I had a PC. And I was really gutted that I couldn't play Wipeout the same as people were playing on the PlayStation. When I saw it on the PlayStation, it was incredible. It's like the first time I saw Mario 64 on the Nintendo. I was like, oh my god, this is going to change the way platform games work, and it did. I mean, all platform games from that point on pretty much followed that mold, and very few have come close to beating it. Um, it still holds up as one of the best 3D platformers of all time. Odyssey, I think, just about beats it. But I think the original Mario 64 was just incredible, really well thought out, amazing level design. Um, yeah, yeah, but yes, exactly. You had to shrink it right. I remember that. Yeah, he did have to shrink it right down. But then again, we had games like Terminal Velocity on the PC, which was incredible and just couldn't be done on the PlayStation. So, okay, set cache index. So let's create this label here. Oh, this find sprite should be up here as well. So set cache index. So this value is in the Y register at the moment. So we transfer that to here and we store that at the cache index, which is in this area. Okay, so that is like 3. So I did like my PlayStation, but as soon as I remember the 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 Nintendo 64 coming out, and it blew me away because for a start, the Nintendo 64 had bilinear filtering. You know, everything looked kind of smooth and not the blurry mess that you. Sorry, it was a blurry mess, but it wasn't a pixelated mess. Things looked smoother, and it was nice. Descent, yeah, Descent on the PC, that was really hard. And the first time I played that on gamepad, and it was not easy. Yeah, the controller is awful on the on the Nintendo 64, but it works for the games that they've got. Yeah. Okay, so there we go. So we've got the cache index set up now. Okay, cool. So now we need to fetch the cache address for the target sprite index. Okay, so that is basically cache address. So that is for the sprite that we want to display, or the cache index that we want to display, which we've stored here. So that's in the it's in the Y register as well, actually, here. So let's put that there. That means we need to grab. Like that, and then we need to store that at cache. Is this the fetch index? No, this is the target. Okay. Okay, and hopefully target and fetch are both set up here. Yes, okay. Target, yeah, okay. Fetch the data address. Okay, so the data address is data address for the compressed frame data. Okay, so that is the value that we have. That's this bit here. So that's this bit. Okay. So that would be no. That would be 0, then load accumulator with that, and then that would be this value, comma Z. Seems like an awful lot of processing for one sprite. It's going to be interesting to see just how much time this takes. So. Yeah, Ridge Racer 4 looked amazing. I think Ridge Racer 4 was probably the nicest looking of the racing games. Gran Turismo 2 was good, but I think Ridge Racer 4 they really polished that to look like proper sparkly arcade good. And they did a very, very good job of it. Okay, so now I need to load the bytes from the data address into the target address. So now set the target sprite pointer. Okay, that's okay. Let's do the unpacking first. So for the purposes of this, we're just going to do our 6 frame unpack, 6 character unpack, which means this needs to unpack 384 bytes, which is a little bit annoying. So what I'm actually going to do is I'm going to make this call uh, no compression unpack, because I'm going to make this into separate values, and then we can call this based on what the compression routine is. So this is going to be kind of a bit long-winded, but I'm going to do it this way anyway, just because it's going to be easier than doing 2 separate. Actually, well, it's probably about right. Actually, okay, not that one. So I need to fetch. Okay, so I need to fetch a value. Oh, and these need to be zp.sprite fetch. Okay. I can hear a record clicking. I'll skip this. Okay, so we're going to grab the cache fetch here, and I'm going to store that at cache target. God, this is a lot of code without running it once. This is kind of slightly mental, if anything. But then what we're going to do is we're going to run another loop exactly the same again, but this time we're going to increase Z. And before we get to that, we're going to increase some values here. So And this is just so that we can copy exactly 128 bytes in the second loop. It's a crazy way of doing it, but this is going to work. So okay, and then finally we need to set the target sprite pointer. So that this is we need to set the values that are in that'll be sprite data pointer low and pointer high. And those sprite pointers come from our it's those, isn't it? It's the what? It's this. It's exactly the same as this. Okay, so that could be a few bytes saved there if I duplicate this. There, like that. Okay, so first thing to do is just to make sure that this is compiling, assembling. Fully expecting to see an error in here somewhere. Okay, yeah, there is one error here. Okay, I feel like there's going to be a few if that's one error. How is that unexpected? Do I have to wrap that in a thing as well? Okay, cache usage. So it's at line 90. Oh yeah, that's this bit here. So again, I don't think we need the Y. Once we've gone past this point, we don't need the Y. It's the Y is just used to work out where we are in the sprite index. So okay, so that's compiling because it's running again here. But obviously now this is pointing to this isn't doing anything. This is just going to load the same data that we were having before, but the code is compiling. So that's a good step. So what we're going to try and do is we're going to try and replicate what we can see on the screen here now. But we're going to try and do that with these methods instead. So instead of just pointing directly to that memory, which is pointed to now, which is what we see in, let's grab this over here so you can see it. These values here, these 0E and 62, instead of doing this, what I'm going to do is I'm going to fill these with 0 zeros. In fact, let me do that by duplicating these lines. And what that should do, hopefully, is it should turn the sprites off. You shouldn't see sprites at all when these are set to 0, 0. If I've set this up correctly. So we should just get an empty screen. Hey, the potato head, welcome. Hope you're doing well. I'm actually running out of alcohol. Okay, it's cool. So we've got no sprites there, and you can see with no sprites, the routine is very, very quick because all it's got to do. Oh yeah, I've got rum. That's a good point, actually. Yeah, I've got rum. So when I've run out of alcohol, just actually. Is there alcohol delivery? Yeah, I could probably get some. I'm not going to though, because I'll wake her up. That would be really bad. Okay, cool. So you can see there the raster time now is just the time it takes to actually clear and kind of process even though they're blank, just process. So it's using a little bit, but it's using a little bit because there's 384 potential layers that it can use that has to clear and set up. So alcohol delivery in the middle. Yeah, we can get pretty much anything we want delivered here in London. Actually, I've not tried alcohol in the early hours because I know there's licensing laws, but I don't know if that applies to deliveries as well. So, for instance, you can get you could have a shopping delivered at like 8 a.m. in the morning, which is outside of liquor license hours. But you could get them to deliver, a 24 pack of beers, for instance. So I'm not sure if it counts for delivery services like that, or if it's just a weird loophole because of the way supermarkets work. I imagine it would be very hard to police actually on something like Just Eat or whatever. But yeah, anyway, it's never a good idea to order alcohol from them because the shops that sell the alcohol on those services are stupidly overpriced. Okay, so we've got a system now. So let's try the most basic of setups here. Let's go into our routine here and see if we can just draw something, right? So let's try and draw um, a frame here. So now the other beauty of this is we can actually call frames by numbers in here. So this is frame 0, 1, 2, whereas before I was having to call it by the character data in here. So I'm going to try and set frame 0 so into sprite 0. So I'm going to load X with 0. So this is our target. This is our frame number. Target sprite index. Target source frame index, or source frame, I'll do. So now hopefully I should be able to do sprite cache dot change sprite. So what I want to just see now is does it generate a single sprite? In theory it should generate one sprite and we should see one sprite on the screen. I mean, I have a feeling it's not going to. It's a lot of code. I mean, it's hours of code without seeing anything, and we don't see anything. Okay. So the first thing is do we actually get into this location? So, I mean, obviously we're going to get into this. This is going to work, but then what happens down here? So let's take a look at sprite pointers in here and see what's actually going on in here. So we can do that by working out where those pointers are. Just do some rearrangement on my desk a little bit, just to some room. Okay, let's find pointer low. See where that is. Oh, no, here. Pointer low is at 29EA. Okay. And if I load up this, you're probably not going to be able to see this very well. I'm not sure I can up the settings on this, but you'll have to trust me on this one. Okay, so 29EA is just showing loaded zeros everywhere, so it's definitely not setting any frame index in here. Although it would be zeros. Would it be zeros? Yes, it would, because it's the first frame index. So actually what we want to look at is pointer high, just to make sure that that's being set as well. No, I don't think it does. I don't think it does. You'd have to ask. You'd have to ask Paul, but I'm pretty sure it doesn't. I know that there are some interesting things that. Ooh, why is it doing that? There are some interesting things that Paul's looking at doing. I don't know exactly what cache lines is, um, but I would be surprised if it implemented them. I probably do know what it is, but I probably don't know it by name. As with everything on this. Is that like the predictive? Not predictive. Oh, okay. Yeah, no, it's not. No. Definitely wouldn't then. Bank Very good, very good. Okay, so I'm looking for pointer high. Pointer high is at 2A. Okay, so let me check that. Yeah, you see, I'm not seeing anything in here at all. Yeah, they're all zeros. So I don't know if you can, yeah, you won't be able to see that, but it's all zeros there, which means that's not working. So first of all, let me just try switching to another sprite instead, another frame, sorry. See if that makes any difference. And then if not, we can go through and see what the hell's happening. Okay, so I'm not seeing any difference there at all. Okay, so I'll keep that source frame in. That's fine. Let's go and have a look at this sprite cache. I mean, this was a lot of code, right? This was a couple of hours worth of code without running anything. So I wasn't expecting it to do amazing straight out of the box. Okay, let's go and have a look at zero page, because zero page should have these values for stuff, and we can see that make sure it's getting those right first. So let's find out where those are in memory. Okay, so sprite cache old index. Let's find that, and then that gives us the 4 locations. So sprite cache old index at 33. Copy the values that I could find at this location, and we'll copy those into here. Okay, so the locations that we have are remember, these are going to be in little endian format, so these are going to be all, but hopefully you can see those numbers. Yeah, okay. Okay, so this one looks correct because that's the sprite cache index. The old index, there isn't an old index, that's fine. So the cache index is correct. The reason the cache index is correct is because this value is actually 7C08, and these are actually at the beginning like that. And 7C08 is exactly one sprite along, as we set one here as the source frame, one frame along from our sprite index location, which is at 7C100. So now I just want to go and check what's at 7C100, just to make sure that there is some data at that location. Okay, so this is the data we have at 7C100. And you can see we have 3 bytes which make up our fetch and then our cache index and whatever, which means our cache index is actually at 8,000, which is exactly where we expect it to be. It's here. That's correct. Which means our first. Hang on, because oh yeah, 7C08. Did I do 7C08 or did I do 7C100? I did 7C100. Okay, so actually it would have been this one maybe. I don't know, 8, yeah, it would have been this. It would have been 8180. Okay, which is correct again anyway. So that's fine. That's fine. Those the data that's been loaded in here. So this is correct, and this value in memory is correct. So that is sprite cache index. So sprite cache index is being set correctly, which means it's been set here and here. So that means all of this is, so we're good up to this point here. Not same. So do we reach this point here? Maybe we're not getting to this point. Okay, so let's do some simple checks. Let's just do an increment here, jump star, and let's get rid of these bits here. CPU synthetics, the CPU caches could be added in theory. So I know that Paul. Oh man, amazing, amazing! Tomb Raider 2 actually came up. What are the chances of that? What are the chances of that? That's crazy. That's actually really crazy. That's That's blown my mind a little bit. And he won't shut up about this for weeks. Yeah. It's the best he's ever done. Oh, I missed one. There we go. The beauty of this is once I've done all of this and I've created these libraries, I'm going to share these and you'll be able to use these without ever having to do all this fucking painful stuff ever again. And you'll be able to just treat the sprite system like the Vic sprite system. Thank you for the follow, Fofan21. Appreciated. You'll be able to treat this like any other Vic sprite system and it will all be good. Where's the fun in that? Well, yeah, I mean, you go for it. If you want to have a go at it, have a go for it. But the point is you won't have to, and that's kind of why I'm doing this. So as I want to make it as easy as possible for people to use. Okay, this is still running, so which means it's not. It means it's always exiting. That means that first check is always failing. I believe if that did actually build and deploy, I don't remember if it deployed properly or not. No, it didn't. Oh, it didn't because I've got this open. So if you've got connect open, it won't run. Oh, oh. So we've definitely hit the hit that point because it's stuck on this screen now. It's not doing any update. That pattern down the screen is the kind of sprite initialization stuff, the RRB sprite initialization. I left it in because it's good to spot that you're in that state. So that means we are hitting this point here. So that's good. So next step is why is it not actually updating further? So let's have a look. So we should be decrease the old frames usage count. So this would be a case of grab the old cache index at that point. Now, do we have old cache in? Okay, so we have this value here, but ooh, should we be grabbing that value? Oh, okay, so first thing I should be doing here is if this value is already 0, is not doing anything. So if that is equal to 0, we skip. That's going to cause us problems later. Otherwise, we can reduce it. And also, if this sprite cache old index is at 0, 0, 0, then we probably shouldn't be using it either. So how to test if all the values in this are 0? I mean, I could just test each value in here. All right, let's put it in. We can always factor it out later if it's too much. So I'm going to take this value plus 0, and then we're going to do this, or so by ORing the 3 values of the 3 bytes. So we don't need to OR the top one because it's always going to be 0. But by ORing these 3 bytes together, if there's still 0, then it will be 0 here as well. In which case, we also don't need to decrease the sprite value. Is the new frame already cached? Okay, so we're going to take the cache index. Otherwise, we're going to find a sprite. So I would hope that we get to this point here, because the sprite shouldn't be cached at this point. So we should get to this. So let's do another block here. So we're just going to do inc. So I'm going to do jump stars -3 because I can see the borders moving, but it should produce the same effect. The game should lock up. Okay, I'm out of wine. So how long have we got left? We've got about an hour left. So why not? Let's go for it. So a bit of rum now. I'm definitely gonna drink wine with Fanta again because that was incredibly easy to drink, and hasn't hit me quite as much. Kraken is being drunk with cherry coke, though, has to be, although it's not cold, which is a bit of a shame. But oh, interesting. So, according to this, then we've not hit this point because we've hit this point here and we're jumping to here. So I think if I put this in here, we should hit that. And if that's the case, then we've got a weird issue with frame caching here. Oh, and I can see what I've done wrong. I can already see what I've done wrong. So here I'm checking to see if the cached flag is set, and if it is set, then we go and find the sprite, which means it's doing the opposite of what I want it to do. We shouldn't need to find it if the sprite is already cached, then we shouldn't need to find the sprite. So if I run, you can see there the border is flashing. So if I run this again now with that thing flipped, it shouldn't find that. It should be the other way around, hopefully, and we won't see that border flash. Oh, we have a sprite. Okay, that's good. Okay, so we now have. Okay, we now have something flying around, but it looks like the data is wrong for this. So it's probably getting the data from the wrong place. So let's. Okay, those values will only have been set once. So let's go and have a look in memory again at this location. So going to get those 4 values again from 33. So these are our 4 values. So our old value, fine. I expect that to be the same. Okay, so what we're looking at, we're looking at Sprite cache hold index. Yes, we know that hasn't changed. 7C08 is our cache index. Our fetch index, now this is interesting, is 8280. And our cache target is 02 EF80, which feels very wrong for some reason. Oh no, this is. Wait a minute. How is that value? Oh, because we're going backwards through. Okay, so that's actually probably okay. So what I now want to do is I want to check those 2 memory locations to see if the values, if the memory at those 2 locations match. So okay, so I've got a long list of. I mean, it's definitely valid data looking at this. Let's see if it matches what we see at 8280. Okay, it seems to match. Yeah, I mean, it seems to match exactly, in fact. So, 2EF80. Oh, hang on. And then it goes wrong. Okay, so there is one bit of an error, but the point is the sprite pointer looks completely wrong though as well. So, so now I want to check that pointer table low and pointer table high match. Hey, Lord Ginsterbush. Ginsterbush. What language is it? This is 6502. Oh, sorry, 45GS02. So it's a modern version of 6502. So it's based on the 665C02 with a couple of 32-bit addressing modes thrown in as well. And I'm using Kick Assembler, which gives it a kind of slightly more modern kind of high level language edge to it as well. So it's still assembly language, but I do have some constructs which you probably recognize from higher level languages like for loops and stuff. Though I'm not using for loops in here, but um, and really those things like for loops, they're just directives to tell the assembler to repeat the same instruction. It doesn't actually create a loop with an increment and a comparison and any branches. It just repeats the code. It's a macro basically. It's just like a fancy macro. Okay, but I think that this sprite that we're seeing now is not actually drawing at the right frames or something, because the data seems to be there, although it seems to be wrong. The first 128 bytes of it seem to be correct, so we should see something correct here, but we're not. What we're seeing instead is what looks like a load of zeros from somewhere else. Although why they're not coming up transparent, I don't know. Maybe there is a black in the palette. Let me just have a check. No, there's not a black in the palette actually, so I don't know where it's getting that from. Um, that's strange indeed. Actually, it should be showing black in the palette. Okay, that's fine. That's a worry for in a bit. Let's just get the sprite pointers right. So I'm gonna look to try and find this. Not that one. Sorry. Pointer low and pointer high. So let's find that. Okay, so that's at 29. Oh yeah, 29EA. Okay, so let's just check 29EA. So 29EA says B9. So let me put that in here. So that's our lower byte of the pointer. And then if I look at 2A, 2A, oh, that's also B9. Okay, so that would imply that the pointer setting is wrong. So let me just have a look. Pointer, pointer, pointer. Oh, yeah, there we go. Pointer low, pointer low. So that's why that's broken, which means it's probably broken up here as well. All right. Okay, let's try that again. To be honest, considering this was mostly done over the course of what, 3 hours or so, after an hour's of explanation, 3 hours without running the code, I'm kind of surprised that so much of it works ahead of time. There's only a few minor issues in here, so it was not easy to work out in my head though. Even with the code written out, I was getting confused by the source and the target, and the fact that we've got this frame index thing. Okay, so it's drawing something. It's definitely drawing the second half of so it's drawing the right side of the sprite. So it should be drawing this here, and that seems to be what it's drawing. This half of the sprite. But we do have this issue at the top and the bottom. Now, the reason we have the issue at the top and the bottom is probably due to the fact that the area that we're putting these sprites in is not cleared first. So I'm going to create an init, and I'm going to create a clear DMA in here. So the way that the DMA system works is pretty easy once you get your head around it. It's just not it's not intuitive. That's the thing. So you need to understand the format a little bit. So I'll go through the format a little bit as we do this. So a DMA is basically a job. It's a list of instructions. These are the instructions here. Actually, this bit is the instructions, and this is the kind of source and destination data down here. And you create these little jobs as little byte packets. They can be chained together, so you can do multiple of them. But then once they're set up, you basically set let me copy it from somewhere else as well, so I can find, because I forget how to do this half the time. Yeah, there we go. So you execute the job by calling these DMA instructions here, and basically I forget what these two are now, but this it's all documented in the manual, so you can check it out in the chipset reference guide here. Yeah, kind of like the copper, but instead of being tied to kind of rasters on the screen. It's I mean it's kind of the same, yeah. Uh, but it's not tied to kind of screen updates. It's a separate kind of co-processing thing, but it's synchronous as well. So even though the execution speed of what the copy happens um, is at 20 megabytes per second is the copy speed. Um, no, it's the DMA magic thing. The CPU is basically paused while the DMA magic does its job. So it's not asynchronous. The DMA magic will basically pause CPU operations, so you don't have to wait for the DMA to finish. You do what you need to do, and then the code after it will run. Um, so let's just put this stuff in. So clear sprite cache. So why do we need to clear the sprite cache? And it's because we need that blank position above and below, right? So on the Commodore 65, the DMA Magic was a separate chip, I believe. I think it was a separate chip anyway. And on the Mega 65, it's just another part of the FPGA. So what happens is when one of these jobs comes, when you trigger one of these jobs, and you trigger it by setting the value in this D705. Once this value is set and written to, it triggers the job of whatever's been set up in the other registers. Um, DMA clear DMA. That's interesting. Pick the same names. Um, it will go and run this job, and then when this job is finished, it will return the execution back to the CPU again. So the CPU does freeze at this point, um, but it's so quick. 20 megabytes per second is insanely fast. So it's kind of surprising how quick it is. Okay, so this is what a job looks like. So the very first byte is the request format. Now there are two formats. There's for F018A and F018B, I believe. F018A is I think it's F018B. I can't remember. But F018A is the newer version and the better version, in my opinion. Um, just trying to find out. It is documented in here. Don't see where it is though. Actually, it doesn't say. Oh yeah, F01A and F01B. So I'm using F01A. It's all documented in here and in the C65 documentation, so you can take a look in there and find out what it is. Yeah, it is exactly what was in the this isn't a Mega 65 thing. This is a C65 thing. They've improved it slightly and they've fixed a few things, but generally it's the same as you would get in the Mega 65. Okay, so oh, there must have been a bug in the music. The music had stopped. What ID is? Oh, okay, Andy's already. Yeah, this is just Sublime with the Kick Assembler plugins. Uh, I do use Visual Studio Code as noted in the tools there when I'm doing Game Boy stuff, just because it's easier to have that environment set up for Game Boy than it is on Sublime for some reason. Likewise, Sublime, I've just got used to using it, and I can't. I'm stuck in my ways now. I can't get out of it. Okay, so the first byte is a request format, and then from that point on, after that, you have um, options. So the options are listed a little bit in here in the manual, and they let you set things like in this case we're setting the bank address. So this is the megabyte address. So these are always going to be zero mostly. It's unlikely you're going to use these unless you're doing floppy sector copying, in which case you'll have FF in here. Uh, this is basically the upper byte of the 32-bit address space. Um, you're almost never gonna set these, but they do need to be set to zero. You do need to actually define them. Um, and then when you finished adding options, you pass a zero in to say I'm done with the option. That's all the options now. That's done. Other things you can set in here, you can set the skip rate for the destination and source. So whether or not you're copying to each byte sequentially, or you're skipping 3 bytes at a time. You also have fractional steps in here as well, so you can do texture scaling as well. So if you want to copy image data um, to the screen, you can do it with a fractional DMA, so you can then kind of stretch and compress image data as well. And that's what Paul is using in Mega Maze to generate the textures on the sides of the maze. So you can create things like doom engines quite easily using this system. There's also transparency stuff in here as well, so you can get a copy to only copy bytes that match a certain pattern. So you can get it to ignore zeros, for instance, and that allows you to copy data from one image over another image and use a certain byte as a transparency image. Really handy for doing character animations in Turrican. The Turrican demo I did, the waterfalls have like a splash at the bottom, and so the waterfall was a DMA copy, which was just sliding the characters down, same way you would do it on the C64, just sliding the data down, but very very quickly. But then the splash where it hit the water was just superimposing another image over the top of that sliding animation, and it allows you to kind of composite two animations together very easy, and that was done with DMA transparency. You've also got actually I think that's about it actually for those. Yeah. Just looking at the list on here. You can check on the online, the C64 documentation that you can find on Zimmer's and stuff has more information about this, and I had to actually use that to figure out some of this. I think really we should probably get. So in fact, I might actually recommend that to Paul to get the documentation from the C65 manual copied into the Mega 65 manual, because I had to cross reference between two. So, for instance, this byte here, once you've defined the jobs, you then have the data. And this is either 11 or 12 bytes, depending on which job you pick. I'm using 0A, so this is an 11 byte thing. You can actually see only 6, 7, 8, 9 here, and that's because there is like a final one here called a modulo. Um, but if you're not chaining things together, you don't need it, and I don't even think this works. I'm not even sure what it does, but you don't need it in this case. So you only see 9. So the first byte tells you what you should be doing. So this is whether it's a fill, whether it's a copy, whether it's a mix, and whether or not you should be doing another job after this one, or if it's the last request. So if it's the last request, we don't set anything else. And in the case of a fill, we need to set 3. So again, you can find these on the C65 manual. So it's the and this is what I like about it, right? This seems like it's super powerful, but actually this is just what the C65 was going to have. There's nothing different about this to the C65 machine. Maybe it might be a tiny bit quicker, but not by much, I don't think. um then the next one is the size of the copy, so you can only copy 64 kilobytes at a time, but that's usually enough, right? In our case, we need to copy the maximum number of sprites times 64 times 7, um, plus at the end we need another 64. Um, but what I'm gonna suggest here is, instead of doing it like this, I'm going to change this to 64 times 8, and this is just going to make sure that the buffer clears all the way to the end, so that when the sprite index oh, actually no, that's going to delete the sprite index, isn't it? Yeah, can't do that. Yeah, can't do that. Fuck. Okay. So I mean, in this case it wouldn't delete the sprite index because it's somewhere else, but in the final version I want this to be in the sprite index. So let's have a look. So 64 times 7 uh times 64 plus 64. Yeah, that's right. That is right. Okay. And then I just need to make sure that that is, yeah, that leaves plenty of room for a sprite index at the end. Okay, cool. So the size of the copy is just how many bytes you need to do it. Now we're using a fill, which means all we're going to do is we're going to fill a value into these. Um, but this tells us how many bytes we need to do that on. If you don't pass in a step here, then the step is assumed to be 1. That is for every for every step in this DMA, we increase the destination and the source by one. You can also use this to define which direction you go in, which is done here. In which case you would need to set a position at the end rather than at the beginning, and it will work backwards, so you can decide which way you go, which is really useful if you're copying screen. So one of the problems you have um, when you're doing shifting screen data is sometimes you need to move things backwards, in which case you need to move backwards through the array, backwards through the data. So this DMA allows you to do that as well. Or Sean, how you might want to twist it. So with the fill, basically this is kind of the source is kind of not important. The only bit that's important is the lower byte of the first, so the very first byte in this 3 byte section of the word, and this is the fill value. So we want to fill it with zeros. That's all we want to fill it with. So this bit here is important. Otherwise, if you were doing a copy, then this would be the address that you need to copy from. And this was, you can ignore this top byte here. The top nibble of this last byte here is used to work out which direction you're going in and things like that. But this nibble here and these 4 bytes here define the address. So if you want to copy from 02000, and you want to copy that to 03000, then you would set this to 000 and then set this to 2 here, and then you would have this copying from 2000, and then you would do the same here but with 3000 here like this, and that's what that would do. But with a fill, we don't use a source value because we're not copying from anywhere, so we just use this the lower nibble of that to work out what we're going to copy from, sorry, which byte we're going to fill the area with. Thank you for the follow, Lord Ginster. Appreciated. Always glad to have extra people on board to see this. Yeah, I've been a programmer, so I have programmed since I was 7 years old. I actually didn't get into programming as a job until I was like in my late 20s, just because I didn't really have the opportunities to get the qualifications, even though I was doing this sort of stuff. And then in my late 20s, I got into programming in various languages. And I went through, from basic stuff like Flash and Java, and I did a bit of C, I did a bit of C++. I did some C sharp as well. Oh man, I did everything, and then I've progressed on from that. Now I'm in my kind of mid 40s. I've decided I no longer want to program as a job, so now I've moved into cybersecurity instead. So now I do cybersecurity, which is cool because I get to use the programming stuff, but I don't have to kind of be at the whim of some project manager that's going to say, "Oh, you need to create this program by this time." So that's really nice. Um, Web developer, front end designer. Yeah. So my well, actually, my previous job before the one I've got currently, I was a technical architect for technical lead for a company. Although I was pretty much doing the job of a technical architect. Um, for front end development basically, so doing front end web development, and mobile development. But the job kind of moved into more kind of architectural stuff, and then before that I was very much just a front end developer. But I've done little bits of everything. I've touched on everything, and now I'm in cybersecurity. I'm really enjoying the programming way more because the programming I do is more for my own stuff. I'm enjoying it a lot more. I'm getting more involved in it, and I like it a lot more. It's just more fun now for some reason. Okay, so clear DMA. So now, what do I want to clear? I want to clear from the Sprite cache base. So this is pretty easy. This is just Sprite cache base. Where's the and button? Where's the and button? There it is. And this is Sprite cache base. Now you might think I have to do FF here because I need to get the top bytes, but actually there's only 20 bits of location being done here, not not 24. The reason for that is because this upper nibble, as I said before, defines things like the direction and stuff. The address space is actually 28 bit, not 32. And because the address space is 28, you have 20 bits defined down here, along with the direction, which is stored in this upper nibble here, and then this here, which defines the upper 8 bits. So as I say, this is source and destination, or destination. I can't remember which way around they go. Destination and source. So this is destination 81, and 82 is source. And these are the upper 8 bits, and these define the upper. I think it's megabyte. I think it actually exactly on a megabyte. 64. No, it's not actually, not quite. But yeah. Anyway, that's the upper 8 bytes. So that should be enough now to clear that area. So if I run this again, we should hopefully get rid of that noise at the top and bottom of the sprite, and then we just need to fix the sprite data. Oh, I envy you, Stoker. I really do envy you. Although I have to say that the JavaScript is really helping me. Oh, it's not got rid of that at all. Okay. Oh, because I'm not calling the init. That's why. Um, the JavaScript is helping because what it's doing is it's giving me 17 sprite cache. It's giving me some tools, very fast prototyping tools. So, I mean, I could probably do it in C# or C as well, but the thing with JavaScript is it's super easy. If you use something like Node, Electron, and stuff like that, you can write scripts that are back end, front end. I can do pretty much anything I want to do just with JavaScript. I don't need to use anything else. The only time I need to use something else is if speed becomes an issue. If speed becomes an issue, then I probably do need to use something else. But I can pretty much do. I mean, my editors are made. This is done in JavaScript. Let me find where is it? Yeah, not that one. My Game Boy editor is all done in JavaScript. Because there's no need for me to use anything else. I can use Electron, and I can very quickly write something which does the job, and is fast enough for it to be useful. So there you go. I mean, it's a little bit slow at scrolling around because it's using canvas to draw all of this. But as I zoom in and there's less to draw, it gets faster. So it's only when you zoom out. And to be honest, this is going to be the same in any language. But obviously in JavaScript, it's going to be a little bit more pronounced. But I can zoom in and it's fine. And this is absolutely fine for me to do everything I need to do to do my Game Boy stuff. It's absolutely fine. This is all 100% JavaScript. But at the same time, if I need to write a quick server, so all my overlay that you see there, also JavaScript. So all the music that's playing now being played through JavaScript, all the overlay that you see, JavaScript, everything is JavaScript. So I don't need to learn 20 different languages to do 20 different things. I can use one and I can use it for everything. So okay, I really do need to pee, so I'm gonna take 2 minutes, guys. I'm gonna leave you with the quizzes, and I'm gonna go and take a quick pee. Then when I come back, we'll work out why the rest of this sprite is meant to be. You can see now that DMA has cleared the top and bottom of the sprite, so we no longer have the garbage. We just need to set the sprite data to actually fill out properly. So I'll be back in about 5 minutes. Well, less than that, 2 or 3 minutes, guys. All right. Be right back. Let me turn that on for you. Set my be right back on. I'm back. Set that. Set that. There we go. Oh, what is that? Sometimes it's really hard to tell because some of the colors. Yeah, I don't know what that is. So even things like the quiz and all the database stuff is all done JavaScript. Why use anything else? That's what I think. And I guess it's one of those things. JavaScript and Python kind of fill the same gap. I think the advantage JavaScript has got is that it's inherent to it's native to pretty much every browser out there. In fact, it is native to every browser. Whereas Python has, I think, the speed advantage, and is probably more, but it's probably more suited to put on that one is more suited to AI tasks than and kind of stuff that uses the system. I mean, Node can do system stuff, but it takes more lines to do the same thing. But I'd still rather use assembly anyway. Still rather use Java. Well, I definitely would rather use assembly, but I'd rather use JavaScript when I have to do kind of far-reaching stuff like servers and things like that. So, but it's just because it's what I know. That's all. Okay, so this is kind of right, except for that the bottom half of the sprite is missing. So let's take a quick look again at what we have. So um, so let's have a look at what we should see in here, and let's see if it's. I just think so. Now I think the only problem we've got is that this is wrong down here. This copy routine is wrong, and really that's it. I think that's pretty much the only problem we've got right now. So if I look at where was it? There we go. So if I look at these memory, I do apologize that you can't see this. I keep thinking I want to make a debugger that will work well with the Mega65. I just haven't got the motivation to do it yet. I guess is the point I'm trying to make. But maybe I should do. Okay, but this looks like it's actually printing more than just the top section. It looks like it's printing more than that. Let me just stick it on the full thing so I can see. Okay, so that's going to about here. So it's doing 4. It's doing a whole section, and then it's failing. Okay. Carl Henrik's jobs. Yeah, I've got to say, right, and I need to start using this as well. The Ice Bro looks really good, and I couldn't get on with it before, and I think it was just because I was having some kind of setup issues with it. Nothing major, but I was struggling to use it, and my fallback to the debugger was just a bit easier. But it's looking really good, and if it's as user friendly as it looks to set up and to use, then it's a no brainer because the debugger is a nightmare to use. So I would like to use something that's better. I would also like to find a way to make that work with the Mega 65. I think that would be a lot harder, but I still think it's possible. Uh, so yeah, it's something I want to do at some point, but I'm not sure if it's going to happen. Okay, so I'm a bit worried about why this is not picking up the right values. Like it's missing some of it's missing some of it. That's what I'm getting at. It's kind of not. It's not displaying the whole thing. It's like it's getting to this bit and it's failing. Like if I just took that out, it would probably look exactly the same. It's what I'm getting at. Oh, pardon me. Why is that not? Oh, because I've still got it open. Okay. Oh God, I can't believe how much alcohol I've drunk tonight. I've done really well. I've done really well. I'm talking like it's an achievement to drink alcohol at a ridiculous rate. It's not. It's a problem. Oh, oh, okay. This is interesting. Oh, okay. Because now it's only printing the top half, right? Now it's only printing. It's just drawing this bit here, which is 128 bytes. It's not even drawing the rest of it. So this is bothering me a little bit now. I kind of want to tell you what the March competition is going to be, and March is going to be a competition. Um, I'll tell you what I will tell you ahead of time. So I've got a plan to do something which is going to be both cycle and bite based. So you're going to be asked to create an algorithm. The algorithm is going to live in a very specific area of memory, so there's going to be no using zero page to do anything. It's purely going to be about optimization. Um, but with all optimizations, optimization is a balance between the number of bytes you use and the speed. So I'm combining the two. I'm not just going to go pure cycles because then you would just unravel every single loop and be the winner. Instead, what I'm going to do is I'm going to ask you to create the lowest score, and the score is going to be generated from the number of bytes that your algorithm takes up, multiplied by the number of cycles that it takes to run, and that's going to produce a final score. And obviously, the best score will be the one that is the smallest that runs the quickest, because multiplying those two together will give you the smallest value. So I need to work out the exact ratio of the calculation, but I think it may just be as straightforward as the number of bytes multiplied by the number of cycles. Um, I will supply you with a piece of code which will measure the cycles for you. Um, but it is the inputs will vary, so there won't be it won't be like make a spiral. There will be an input which can be completely variable. And I'm expecting you to deal with that input and process it in the way that I try not to reveal too much about how I'm going to do it, but you're going to get an input and you're going to be asked to process it in as quick a time as possible and as few bytes as possible. And the winner will be the one with the lowest thing. I don't know what the solution is going to be. I have no idea, but I know what the challenge is going to be roughly. Um, I'm hoping it's going to be an interesting one, and I'm hoping it's not quite as I'm hoping it's not quite as bad as the spiral one. The problem with the spiral one is there was too many opportunities for optimization. You had the algorithm, you had the initialization, you had the optimization of various things like 16-bit maths and stuff. There were lots of little places where you could do some crazy stuff to gain stuff. This I'm hoping will have a little bit less of that in it, but will still be interesting enough to pique people's interests. And it will be C64 based as well, so there will be no fighting against the basic interpreter or anything like that. Praise be the spiral, indeed. Okay, I'm sure it'll turn into an. I'm hoping it doesn't. I'm deliberately thinking of something that is going to be a little more um a little less kind of there are not so many kind of crazy avenues that you could go down, not so many rabbit holes that you can lose yourself in. I think once you come up with an algorithm, you're probably not going to try and change it too much, and by yeah, you're not going to spiral out of control. By giving you a set area of memory that it's going to load from. So I'll tell you now, it's going to load at C000. Your algorithm is going to live there. It's going to be called by my routine, which is going to do a JSR C000, and it's going to time the amount of time it takes for that routine to run and return, which means you've only got uh, 4 kilobytes maximum that you can use. Um, you're not allowed to use any more than 4 kilobytes, and yeah, that's it. There's going to be no zero page kind of loading the code into zero page. No loading it from the stack. The byte count is literally just going to be how many bytes from C00 onward. It's not going to be the size of your PRG. Just how many bytes at that location do you use, um, multiply by how many cycles it takes to run. So it should be a bit easier. It should be compared to the spiral competition. It should be a little bit easier, um, and it'd be interesting to see what approaches people take. Anyway, that's all I'm going to tell you about it. I've got it planned in my head. I may share it with. Well, there's only 3 people I can share it with, which is the 3 people who've already received a Nexus. So it would be Monsters Go Boom, Andy, and Crazy. UK. They're the only three people I would possibly share my idea with and get some feedback on. The rest of you are fully eligible to win one, so I will leave you to go for that. Okay, why is this only grabbing the first one? This is like why is it only drawing the top half? Am I missing something? Is my cache fetch wrong? Let's have a look. Okay. So I did check in here against these values. So fetch and target, right, is what interests me. Which is basically if I take these values here and put them here. So we get 1, 2, 3, 4. So this is wait, hang on, it's all right. 1, 2, 3, 4. Yeah. Oh, see, look, this is different. This value is different. Oh, it's different because I haven't incremented this here. Okay, that's fine. But let's have a look how that actually works in terms of memory. Because I'm not sure that's correct. So if I look at 8180, and again, I apologize that you're not going to see this value quite correct because it's kind of hard to see with this thing. Okay, so 8180 has a load of blank space at the beginning. Interesting. Okay. So immediately that tells me that that's wrong. So let's go and have a look at Sprite index and see what that says. So what are we trying to load in? We're trying to load in the first frame. Well, actually, it's the second frame. Frame 1, not frame 0. So that is, and let's just shrink this down so that it fits perfectly to a line. So that's this one here. So it actually does say 8180. So it is pointing to 8180. So I think our sprite data is actually including spaces in it, and it shouldn't be. Because that means our sprite is 384 high, right? Because if you look at 6 lines times 64, oh, I'm in hex, that's why. God damn it. Phew, that's. I was thinking, God damn it, maths has changed suddenly. 384. So that's 180. You can see there 180. But oh, actually, no, that's right for sprite data. So that is right for sprite data. But what we're seeing, if we look at that location, is a load of blanks, right? And the reason we've probably seen a load of blanks is because what we've got here is 128 blanks of 0. So it looks like it's actually including the spaces in this routine. This again, this is a JavaScript routine which is converting the data from Sprite into whatever it's called. Well, not Sprite. It's converting it from Sprite into the Mega65 format that we need. But it looks like here we're actually adding more than we need to add. Sprite height, sprite data length. Okay. So this is what's bothering me here is that this should not be creating anything other than this section. And this section should be each one of these should be 384 high, which is what we're getting at this side at this side. But what we're actually seeing in the final result, so we're taking this file here. What we're actually seeing is a group of spaces above and below it, which is what we need for the final thing, but not what we need for this. So let me just run that again, just make sure that that's actually in the right data. I feel like something's off here. So I need to go and have a look at 8180 again. In fact, I'm going to go and have a look at that whole area to see what the sprite data is actually output there, because I have this awkward feeling that sprite data is very, very broken here. Get char data from chars. Oh, maybe that's adding the spaces in. Okay, let me just put this in here. Let's call it CD. It doesn't really matter. It's a test thing here. Actually, yeah, it's fine. Just want to see what the length it's outputting there is, because I have a funny feeling. Oh no, it's 384. Look, it's the right length. So why on earth, when I put this in 8180, that's fine. Zeros, yeah, and then 180 is down here. I mean, it's not zeros, right? It's I mean, that should be correct. I don't know why that's wrong. God damn it, so close. Oh, so a little bit of news about well, there's a few bits of news about Dot Cosmos actually. So the first one is that the pre-orders for Dot Cosmos Game Boy are going to open at the end of March. So we've moved it to the end of March from the beginning of March because we just want to make sure that we want to make sure that we can produce the cartridges in enough time to actually store. So there's two ways we can do the cartridges. We can order them blank and put the data on ourselves, or we can have the manufacturer of the cartridges put the data on for us. So we're going to go for that second option, but that means we need to have the game in a place where we're happy with it to be. Shit. Okay. Thought I had more coke, but apparently I don't. All right, it's going to be a strong rub. We're going to have the yeah, we need to have the game in a situation where we can give the cartridge manufacturer the ROM and they can put it on. So I'm getting a test cartridge soon. I mean, it will arrive in the next week or two, so I can test the game on it. But in order to do that, what we need to be able to do is we don't want the pre-order to be too long. So we're looking at maybe 6 to 8 weeks for the pre-order. So we're going to open the pre-order at the end of March, which basically gives us till the middle of May before we actually need to order. Before we actually need to start shipping the cartridges out. Now the cartridges are coming from Australia, I believe. So they're going to take a little bit of a while to get to us. So we need to make sure that in the middle of April we can send them the ROMs to put on there. So that gives me March and April. It gives me about six to 8 weeks to finish Game Boy dot Cosmos. So I'm going to be doing a little bit of that off stream. Things like the music routine and stuff I'm going to have to do off stream. There's things like mapping as well. Probably going to do a lot of that off stream. And I'm probably going to try and stick to doing. I mean, I'm absolutely going to do the Game Boy every Tuesday. I'm not going to replace that stream at all. That's going to just be Game Boy every Tuesday, and hopefully over the next 6 weeks we're going to get the game into a position where we can test it. So when it comes to actually ordering the cartridges, probably round about the end of April, we can get those. I can test the game and I can get it onto cartridges by then. The other good news is as well that I've been thinking about the original Dot Cosmos. Oh Jesus Christ, that's stronger. I'm going to put some Fanta in that as well. And the original idea with the original Dot Cosmos was to wait until the RGCD competition winner had been announced, and then to give RGCD the rights to kind of release this game on their own label. Now, since then, there's been several games that were put into the RGCD competition that have been released. So Neutron was released, Vegetables was released. I think there's more as well. I can't remember what else, but there's a few other games that have been released, not through RGCD, and various levels of kind of. Actually, it was Neutron. No, Neutron. Wait a minute. Am I? What am I thinking here? No, Neutron wasn't released. Neutron was just kept as it was. I think there was like a Christmas version or something, but some Vegetables definitely was released on cartridge. So I'm gonna do a Dot Cosmos C64 version on cartridge, and I'm gonna do that with enhancements as well. So the stuff I've learned from doing the Game Boy version is going to be implemented into the C64 version. So I'm going to try and upgrade the backgrounds a little bit, try and do some stuff to kind of enhance it a little bit. But what I also want to do is I want to make it a truly deluxe version. So I want the C64 version to be the definitive version. So we're going to go with the same artwork from the Game Boy version. I'm going to change the logo in the game to match the artwork. I'm going to upgrade the map to be between 5 and 10 times the size. Bear in mind that the only reason the game is the size it is because it was 16K game with a cartridge that opens up a whole different world, and I can my level editor for the C64 version is really good, so I can really pump out the levels on that thing. So um, that will be something I don't do on stream. I'll be doing that off stream, and it's probably going to be a slow process. Um, but I'll be trying to release that at some point, maybe this year. I'm not gonna commit to it because I don't know. But I would like to maybe get that out this year. Um, but yeah, so that's some interesting news about Dot Cosmos. And once I know more about that, I will also have T-shirts as well. We'll have some Dot Cosmos T-shirts with the new artwork on it, which, as I've said a few times, is really good artwork. I can't wait to show. Oh, that does not taste good. Fanta, cherry coke, and rum is a bad combination. Just wanted to put that out there now. Would that also be available as a digital CRT image to use for Ultimate? It probably would, yes. Now, I don't know whether that would be in Gmod format. Don't, I'm not sure. I would have to find out. But there's no reason I couldn't do a Magic Desk format as well, which would work on the Ultimate. So if we do go about releasing a digital version of it as well, I may change the digital version to not be Gmod, so that it will work on the Ultimate. Because Gmod will work on the later version of the device, but it will not work on the Ultimate. So I might do it like a Magic Desk or an Easy Flash version for the Ultimate. But basically, it will be dock as you know it. The majority of what you know already in dock will remain the same, but there will be bug fixes, there will be graphical upgrades as well, so things like background and stuff, maybe parallax, I don't know. No, probably not parallax actually, because there won't be any scrolling, so there won't be any parallax. um but the map will definitely change in size. I want to make the map at least 4 times bigger, but I would hope to get towards 10 times bigger, which would mean going from about 50 screens up to about 500. So it would be a bloody huge game if I get it good. So will I be able to get past screen 10? Probably not. um, probably not. But I may put passwords in it. So I don't know how it's going to work yet. I don't know how it's going to work. But I've been talking to Bitmap Soft about doing this properly. So and it has annoyed me that I always intended to get this game out, and I did want to do it with RGCD as a dual game thing with Dock 1 and 2 on the same disc, same cartridge. But as I've kind of not stepped away. I mean, the get Dock 2 is definitely still there, and it will come out eventually. Um, but as I've kind of moved towards the Mega 65 for the meantime, Dock 2 is almost definitely on kind of indefinite hold. And I don't see RGCD announcing a winner for that competition anytime soon. So I would just like to kind of get that game out there. I've wanted to get it out there since the start, but the only reason I haven't is because I thought it was the right thing to do to allow the competition to play out first, and it hasn't played out. It's now been almost 2 years since the competition ended. It's been 2 years since it started, and it'll almost be 2 years since it's ended. And we still don't know who the winner is. So I'm just gonna accept that that's probably never going to be announced and just go ahead and release it with Bitmap because Jamie's been really good to me. Bitmap I've worked closely with him. I really enjoy working with him. He's very thorough. The quality of their stuff is really good as well. So I just want to give them more of a more content that they can put out there and actually get Dot Cosmos onto a physical C64 cartridge. Anyway, let's get on with this. So where was that? I was trying to work out why this is only drawing the top half. Why is it showing blanks in the bottom half? Let's have a look again. Okay, so 8180 is where the data starts, but you can see it starts with a load of zeros, and that's what I don't understand. Where are these zeros coming from? It just doesn't make any sense. And indeed, if I look at 8,000, I get the same issue. So let me have a look at what I'm importing. Maybe I'm importing the wrong thing. Oh, because I'm importing unpacked. Fuck's sake. All right. Fucking hell. All right. I had all the spaces in because I was importing the wrong bloody file. All right. What happened to that? You mean RGCD? I don't know. See, at first I thought it was because they were busy doing other things. I just assumed that there was something personal life things going on or whatever. But what I've noticed over the past year or so is that they've managed to output lots of cartridges. There's a lot of Savona stuff has been on RGCD releases, so they're active, they're doing stuff. They're just not doing the competition that they set up and did. And there's people in the competition that would maybe never have done something like this before. So in a way, it's good that they're doing that, but at the same time, it's kind of a little bit shitty that you don't follow. I mean, I committed to doing this cassette 50 thing, right? I've said I'm gonna go through every cassette 50 game and make sure it loads from tape. Do you realize how difficult that is? I mean, it's nothing. Uh, I mean, the RGCD judging is nothing compared to what I'm going to have to do to get however many games it is, probably 50 games, and that's working perfectly. Awesome. I'm gonna have to get all those games working from tape. Now, bear in mind that I stupidly made the rules up so you could use the fucking tape buffer. So now I've got to work out a way of um, rewrapping each one of these games so they work from tape. And I've got to do that at the end of March. At the same time, as well, I've also promised that at the end of before the end of the competition, that I will go through and I will verify every single game to make sure it obeys the rules and contact people if it doesn't. So I've set myself up for a lot of work here, and I'm still gonna fucking do it. And I've run 3 streams a week and work on many projects, but I'm still gonna bloody do it. So it just annoys me that um people have put the time and effort in to enter this competition and they've done nothing about it. And they've been very quiet about it, which is the most annoying thing. They've not said, anything about it. I am angry drunk now, aren't I? I am angry drunk. Right, I'll shut up, yeah. Yeah, I just wish they'd say something about it. It just pisses me off a little bit. But whatever. Okay, the cool thing is, look down there. No, no, there. Look down there. Shouldn't have mentioned it. No, it's fine. It's fine. I get annoyed about things, but I think it's fine to get annoyed about things. I don't think it's unusual to get annoyed about things. I think it's perfectly fine. Um, it's just I'm not grumpy. That's the word. I'm grumpy about it. That's all it is. You know. I realize RGCD have probably got lots and lots of things going on, and the competition doesn't really is harder than maybe releasing a cartridge. But if you're gonna create something, just follow it up a little bit, or else you kind of lose the respect a little bit of the people who have kind of jumped in and kind of jumped on this competition. So myself included. Okay, so what I'm going to do now is I'm going to try putting multiple frames in here now. So what I'm going to do is I'm going to create. I'm going to start at X0, yeah, like so. And I'm going to create Y as 0 as well. And now what I'm going to do is before I go into this routine, I'm going to push my X. I'm going to push my Y. So I've got it, and I can grab it back again. Now I'm going to increase the X, and I'm going to increase the Y. And if the Y reaches 16, then I'm going to reset it. The easiest way to do that is just to AND it with 0F and transfer it back to the Y again. And then if I compare X to whatever it is, max RRB sprites, it's not equal there. So hopefully now this should set all the frames up for the sprites. And if this works, then we can start testing how quick it is. Did Dog really win? Just so you know, right? It's not even about that. I don't really care who's won it at all. Oh, something's failed there. What's failed? Oh, I think we've reached this bit. I think we've reached this here. I don't even really care who's won it. What I care about is that the no contest does no contest does I don't know what that means. Oh, okay. So so every entry is the same. Okay. Okay, I'm not sure why, but this is kind of failing if I put too many in. So let's try again, because it seems to be locking up here for some reason. I don't know why it's locking up. Is it this? Increase X, increase Y. Pull X, pull Y. Yeah, I've done something weird here. That's why. Oh shit! I know why, because I'm doing that the wrong way around. So it's just going around in a loop because I'm manding all the time. So yeah, I'm feeling tired as well. I'm going to end fairly soon. But I hope you guys can see from the what's been going on the past. Oh god, those sprites are completely wrong. What's been going on the past couple of what the fuck is going on there actually? Increase Y. Okay, what if I don't use Y at all? I hope you guys can see that the bitmap soft are actually very very good and very active in the scene. They're not silent like a lot of the other publishers. They're very active. They've got an active Discord which is kind of everybody's involved in, and they really are just a part of the community, and I really like that about them. But what is going on here? This is bizarre. Target sprite index, change sprite. Okay, yes. I just set one in here. I don't know why this is so wrong. Something weird is going on. May have to continue this through the week. So I'm probably going to continue this. Probably do this on Thursday. Actually, I think I might skip Checkanoid for a week. Just because I kind of need. I'm at the point now, really, with Checkanoid where I need more stuff from it, and I need to spend more time, probably off stream, fixing debuggers and stuff. let's just do one sprite, see how that works, and then try and do another sprite directly after it. Yeah, it's the other way around. Grateful Tomato. The Mega 65 screen is just the Commodore 65 screen, which was out in the mid 90s. So so I think the Commander X16 has kind of just used the C65 screen rather than the other way around. The Mega 65 isn't doing anything new. It's just in fact the Mega 65 is just the Commodore 65. That's the way to think about it. Um, it's just it has an enhanced mode on it, so that's why it is what it is. You can see there it's using it's the same ROM basically from the Commodore 65. Well, I'm glad Doc won the oh, hang on. I'm just doing this wrong. It's official. Dog wins. Well, it looked like it was quite difficult for it not to win. Thing is, there was a couple of really good games on there as well. I mean, Neutron obviously was on there, which is hard, not to say is a great game. So, okay, let me try for I. I mean, this is terrible. I'm not going to use this in real code, but just for demonstrating. Hopefully, this is fine. Lodex. Oops. I. How many do we actually have here? Is it 16? Yeah, it's 16. Okay, so this would be fucking I can't type. I definitely drank too much tonight. It's great coding, not a great game to be fair. I mean, I've said this about Neutron. I mean, if Neutron is what you're talking about, I can't remember. But yeah, technically it's amazing. For me, I find shoot 'em ups very hit and miss. There's a few shoot 'em ups that really stand out for me. Um, but I don't think it's got anything to do with the coding. I think it's everything to do with the design, like the game design. And I don't even mean the graphics. I mean the way that they play, like the actual user experience of the game. And for me, Neutron and Soul Force, and I know this is a really unpopular opinion, they just don't they don't they don't do it for me in the same way that some of these other games. For instance, look at R-Type on the C64, right? R-Type on the C64 is an absolute masterpiece of user experience gameplay. It's absolutely spot on. And while Soul Force is technically better, Soul Force has better graphical effects going on, and the size of it is incredible. There's a lot of stuff going on that makes Soul Force absolutely amazing. It's nowhere near the gameplay of R Type. I'm sorry, it just isn't. So R Type stands above and beyond almost every shoot 'em up on the C64. Um, and it comes down to gameplay. It comes down to user experience gameplay. It's got nothing to do with the music. It's got nothing to do with the graphics. It's everything to do with the way the game plays. And R-Type is just a great game. It's been designed as a great game. Even Armlight, I don't think is a patch on R-Type. Armlight is good, but it's not a patch on R-Type. I think Armlight is slightly better than Soul Force. Um, I think Soul Force looks really nice. I think graphically it's incredible. The parallax stuff is really good. It's really well done. The timing, the kind of cycle timing that's been done in Soul Force is a work of art. I mean, you to get everything running the way it's running in Soul Force at the speed it's running at, and to maintain a decent frame rate without slowdown is is a work of art. I mean, that's a hard thing to do. That's a very hard thing to do. But I just think Armalite and R Type are better. I think R Type is brilliant. Um, R Type with the drone that goes out and the charge weapon, you just can't beat it. It's so good. R Type is actually incredible when you think about it, what it does. Um, Anyway, that's my opinion. Anyway, I realize it's probably unpopular, and I realize Soul Force has got kind of rave reviews, and everybody's saying Soul Force is the best shoot 'em up on the C64. But I disagree. But that's just my personal opinion because I don't look at it as I don't look at the best game as being the most technical. If you were to say which is the most technical, I would probably say yes, Soul Force or maybe Enforcer are the two most technical shoot 'em ups. Um, but I think in terms of pure joyous gameplay, I think R Type absolutely kills it. Absolutely kills it. Um Also I think that direction of shoot 'em up is so much better than the vertical shoot 'em up. Vertical shoot 'em ups are easy. Vertical shoot 'em ups are too easy to kind of to make, and I think the shoot 'em up construction kit has kind of spoiled us with those a little bit. Okay, that seems to be right. So what I want to do now is I want to change things every frame and see what happens. So I'm going to stick this in the middle in here and just see how much recaching these 64 sprites. Hopefully, we shouldn't see any change. If the caching is working correctly, it should recognize that these sprites are all already cached and there shouldn't be any change down here at all. Um, we should see pretty much the same sprite, the same raster time down at the bottom. Tell you what, I'm really looking forward to from Sarah is the Briley Witch Chronicles because I think the stuff she's doing with RPG on that hasn't been done on the C64. There isn't anything like it at all. Um, it's closer to yeah, it looks incredible. It looks closer to the sort of stuff you'd see on the SNES than it does on anything else, or maybe like later NES stuff or early SNES stuff. It's that good. She's got things like macro spell systems in there and stuff, which is like, why would you even think of putting that in a C64 game? But she's done it. Um, it's good. I think that is where she can really shine with the technical stuff because there isn't a lot of competition there. So in terms of RPG, she's going to stand out way above everything else. Whereas with the shoot 'em ups, I know there's a lot of kind of elevation of what she's done, but I know it's unpopular, but I honestly don't think what she's done is as good as the best shoot 'em ups out there. I think that it's good technically, but it's not as good gameplay wise. But I think Briley Witch is gonna be really good. I can't wait to get that game. That's one I'm gonna buy as well. I Soul Force and Zeta Wing, not so much. I'm not gonna buy them on physical cartridge, but Briley, which I will. I will want more than just the digital version. That I want the cartridge version. Okay. Why is this not working in this context? What's going on here? So if I do that here, it works. But then if I do it in a constant loop, it breaks. Okay, I think that this might be the point to stop. To be honest, I'm feeling quite drunk, so it's nice when a game brings something new to the table to do with it. Yeah, that's kind of what I'm getting at with the game. There's nothing really new about it. It's just a very technically great game. Same with Zeta Wing as well. There's nothing new about it. There's no in no real innovation in there. I mean, there's a say that there's technical innovation in there as well, but uh, I realize I'm going to sound like an arsehole. I'm going to sound like an arsehole. I'm going to sound like I'm picking at things when I shouldn't. But for me, the most important thing in a game is the gameplay, and I've always believed that, and I've always thought that um, everything anybody ever makes that's a game should have gameplay as the primary focus on everything you do. It can look good, and it can be a shit game. If it can look shit, and be a good game still. It's kind of hard how to describe it. Like a good game will always be a good game, no matter how it looks. But a bad game will always be a bad game. You can't graphic your way out of a shit game. Whereas you can gameplay your way out of a shit looking game quite easily. Gameplay is what people remember, not graphics. Okay, I don't know why this is not working in this situation, but well, what I'm going to do is the code is kind of there. We'll probably take a look at it this week. It's not going to be something I do on stream. I will have another go at this on Thursday. I don't know what I'll be doing on Thursday. Probably implementing the basics of the collision system because I need to think about how the collision works. Yeah, see, it's doing weird stuff when it's being done in a loop like that, which makes me think the caching isn't quite up to scratch. Oh, but that's fine. I can work that out. I'll work that out probably tomorrow, and then have a look. So what I want to do soon is start looking at the collision because I want this game to be a little bit more than your average platformer in that I want it to be a bit like Flashback, and that you've got ledge grabs and kind of drop downs and things like that. Pad for 7 minutes. I can't. I really can't. I need to go to sleep. I need a toilet. I need to go to sleep. And the this drink, the rum, Fanta, and orange, disgusting. I can't drink it at all. I tell you what. I tell you what. There you go. You just got it on instead. So go for it. Um, yeah. So I think on Thursday we'll continue this. I'll do some. Oh, I know what this game is. I fucking love this game. I used to get very stoned or take acid. Yes, I was a bad boy, and play this game, um, because it used to send me absolutely mental. Yes, Steps is right. Steps is right. So anybody who copies Steps' answer is gonna get it. It was never actually called Trailblazer 2. It is Trailblazer 2, but it was never actually called Trailblazer 2. But it is technically Trailblazer 2. No, it's Cosmic Cause, not Cosmic Causeway 2. Oh no. Yeah, I used to play that game a lot, and I used to play it when I was kind of a young rapscallion on my drugs. Of course, don't do drugs, kids. Don't do drugs. Very impressive game as well. Technically, it's got some really cool techniques in it for doing stuff. They do a couple of levels where it's obviously just a flat plane, but then you get like an upper plane as well. So you get like these two effects going on, which must have been quite hard to calculate. But then on like level 4 or 5 or something, you get walls coming at you as well. So not only do you have these kind of floors coming at you, you get walls coming at you as well. Crazy. Oh, did it? Ah, I'd have to read that because that must have been an old one because I haven't seen that. But yeah, oh, Turrican winner right at the end as well. Do you bet on Turrican? Anybody? Oh, nobody bet. Prow bet on Turrican. Gutted, gutted. Yeah, I need to order the early ones. I've only got the later stuff, so. All right, guys, I'm gonna take it there. I think we've got a little bit later than we normally go on Saturday. Let me find someone to raid. Duke's on. Oh God, pardon me. Let's raid Duke. I don't know what he's playing. It's just a black screen, but let's just raid him anyway. Yeah, no worries. I've enjoyed the stream as usual. It's been cool to do a, a Mega65 stream. It's I mean, obviously it needs a little bit of work, but the basic concept is there, so that's good. I'll just figure out what the hell I need to do through the week, and hopefully by the time we get back to this on Thursday, we'll be on to another section. I mean, we need to do animation and stuff. Oh, thanks for the cheers as well, Andy. I missed that. Thank you, dude. Um, cool. All right, let's go and raid Duke Donuts now. I have no idea what he's playing, but it's bound to be something retro. So let's go and raid him. And I shall see you all on Tuesday for some more Game Boy. I think I'm probably going to do intro and completion stuff on Tuesday rather than mapping. And I'm going to stick to the mapping off stream, I think. Okay, cool. I'll see you all on Tuesday. Cheerio. Bye.